In this video, we are going to be making stock prediction dApp with NextJS. I'll be showing you guys how to utilize something called the Pith network. If you don't know what the Pith network is, it delivers real-time on-chain market data to the Solana blockchain. You'll learn how to utilize this oracle in your Solana smart contract to get real-time data on stocks like AMC, Amazon, Google, and even crypto if you'd like. As a bonus, I'll show you guys how to make price predictions on these stocks so that you can bet money and win big and get some SOL. Of course, I'll also teach you how to connect your wallet to this dApp using Phantom Wallet, and also how to get your funding connected to your Solana program. So without further ado, let's get started. All right, so here's the app in its full entirety with all the functionality working. I have it open up twice because this needs 2 players. So that means when you deploy this app, you can have any of your friends or somebody else play against you to bet on the stocks of this app. So as you can see, 3W is player 2, 4A is gonna be player 1. So, and you have a couple stock options. There's Bitcoin, Amazon, Google, right? So let's work with AMC for now. And what we want to do is put a prediction out there. So the current stock price is 4. So let's do something simple. I want to make player 1 the winner. So we're going to do it's going to be $4 in 2 minutes essentially. And I'll even bet 2 Solana for this. So I hit submit. And you can see when you approve the transaction, it says send to Sol. So when I hit approve, it's going to send it to a third-party account. It's an escrow. So when the bet's finished, it's going to distribute it to the winner, whether that's player 1 or player 2. So let's hit approve. And after a second, you should see approve bet or failed to approve bet. And there you go, created the bet and it should load. We can go to player 2 and you can see the bet once it loads. And there it is. So let's enter this and I'll say $8 in 2 minutes. It should be wrong, and it's going to send 2 SOL as well because that is the pot amount to enter, right? So the player 1 always sets the pot amount. So as you can see, the total pot amount is 4 to the winner, and now we can hit claim. So if I go here, this should update to claim in just a second. So now it's claim, and after the 2 minutes is up, we can go ahead and claim the bet. And the cool thing is that no matter who is the winner, you can still claim it. So let's say player 2 lost, you can still hit claim, but the money will still go to the right person, player A. Okay, and that's set up in the logic, which I'll show you later in the video. So I'm gonna wait till the time is up and we can hit claim. Alrighty, so I think enough time has passed. So let's go to player A and claim the bet. Hey, see that? We received 4 SOL because that means Solana determined that we won and our prediction was closer to the actual price. So let's hit approve, claim bet. And now you should see the state update. So player A won as well. Player A is on a win streak. He's killing it. He knows all the right answers. So if you look, now we have 5 Solana when I just had 3 earlier. And if you go to player B, if you look at his, right here, he should have 2 SOL, right? He had 4, now he has 2. There you go, that is the demo. So if you want to learn how to build this, let's just dive right in. All right, so you're probably wondering, how do I get started, Lance? Well, you could copy what I do as I get started, but we have Frontend for you guys. And all you have to do is use our CLI tool to get it. So let's do Command J and make sure you CD into a folder where you put your projects. I put mine here, so that's fine. So all you guys have to write is npx clever programmer at latest. You'll get all the modules, all the front end that you need, and have access to every single build in our YouTube channel within the last year. And from there, you could copy and change these projects and add it to your own portfolio or follow along on YouTube. So let's do npx clever programmer at latest. And be sure to build this project with me and try to do it on your own as well so that you have a deep understanding of it. So all you have to do to get access to everything is just type in your email address like so, type in your name, and bah, or bam, I said bah. But there you go, we have tons of projects here, a lot of Solidity, a lot of Solana, but the one that we care about is the Solana prediction app. So hit enter, and this will make sure that you have all the modules and files you need. So there's no more of those node module dependency errors. And all you have to do is just wait for this to finish and it'll open a new VS Code for you. So once that's done, I'll cut back and we'll get started. Alrighty, so if you made it this far, you successfully downloaded the files that you need to get started. So all you have to do now is just say yarn dev and start the server. Right, it's gonna be on localhost 3000. So you could do like a control click. And if you do that, your browser should open and you can see this is what we're working with. It's different than the demo because if you look at the top right, there's no Phantom wallet connection, and none of the other features work just yet, right? Our goal together is to make this static site work, right? So we can learn a lot about Solana by making this work together. So right now it says creating bet right here, which means it's just a function that just console logs creating bet, but nothing actually happens. So what do we need to do first? The first thing that we should probably do is let's get Phantom, right? So if you don't know what Phantom is, it is a wallet that we can use to connect to our dApps, right? There's multiple different kinds of wallets, but today we're gonna be using Phantom. So if you never had Phantom before, all you have to do is type in Phantom wallet, and it's gonna work with Chrome because there's an extension for it. So Phantom wallet extension is actually what you need. And I'm gonna hit Chrome, and there it is. I already have it, so we're good to go. And if you know how to set Phantom, feel free to skip a little bit ahead in the video to the next part. But go ahead and add this extension, open up the Phantom here, and it's gonna ask you to set your password and remember your phrase. So don't share that phrase with anybody or else they'll be able to get into your wallet. So I'm just gonna write my password, and as you can see, once you make an account, you should see something like this. So it says wallet number 1, I have 9 Solana, and you can go ahead and go to your settings. You just click this button right here, developer settings, and make sure your network is DevNet. I repeat, make sure your network is DevNet. Otherwise, a lot of your stuff isn't going to work. There's also the mainnet, which is he's going to use real Sol, testnet, and DevNet and localhost. So again, DevNet, and you should be good. Once that's done, if you want to add some Solana to your wallets, there's a couple different resources, but you can use what I call Sol Faucet. Just take your wallet right here, and you can copy the address with this, paste it on here. You can add up to 2 and click DevNet. And look at that, successfully airdropped to Sol. And now let's see how much I have. And we have 11 Solana. So stock up on Solana because we're going to be testing with it a lot. So with that said, you should have Phantom extension installed. What we can do next is set it up on our app. So we don't have to worry about the browser right now. Let's go ahead, go to your VS Code, and we're going to be working on the index page, or actually the underscore app page. And now when you're in your app.js, this is where we're going to set up the connection provider for our wallet, and so that we can connect to the Solana chain. So one thing that we can do to make our lives easier is if you go into the utils folder, you'll see a couple files that I set up for you. What you want to do is go to constants.js, and let's set up a couple different things. The first thing I'm going to write is export const rpc underscore endpoint. Right, if you don't know what RPC endpoint is, this is essentially a node that we use to connect to the Solana blockchain. And there's a lot of different endpoint providers out there, like Infura, QuickNode, Alchemy, but today we're going to be using QuickNode. All right, so do something like this, and all you have to do is go to QuickNode and let's get an endpoint together. So we're going to go back to the browser, right here, and let's head over to QuickNode. Okay, so go to quicknode.com or click in the link in the description so that you can get in right away. All you have to do is click sign in and create your account. So go ahead and do that, verify your email, and your endpoint should be good to go. I already have an account, so I'll just quickly log in. And bam, once you confirm your email, you should see something that says create your endpoint. So right now I have this endpoint called Bold Stylish Voice, right? But I'm gonna go ahead and archive it so that we can create one together if it's your first time. All right, so feel free to use whatever endpoint you like. But in the meantime, we'll do with this. So archive that endpoint, and this is the exact screen that you guys should see. I'm gonna go click create an endpoint. And again, it supports multiple different chains, ETH, Bitcoin, Polygon, Avalanche, right? But we're using Solana, of course. And quick question, which net are we gonna be using? Main, testnet, or DevNet? Exactly. Good job, George. It's gonna be DevNet. We're gonna go ahead and continue. And there's a couple other extra features like an NFT fetch tool, but we don't need that. Let's just make the endpoint down in the bottom right. All right, give it a second. And there you go, right? And guess what? That's it. That's all you have to do to set up an endpoint. If you were to do this yourself, it would take a lot longer. So let's go ahead and click this copy in this HTTP provider, and that's all we need. So you can go back into your code now, and in the quotes, after you made this variable in your constant.js, you should have one. Just paste that bad boy in there, and guess what? You have an endpoint ready. All right. So now that you have your endpoint and you're exporting, we can now go back to our app, and we're going to be using that endpoint soon. To use it though, all you have to do is, if I make this bigger for you guys, go into here. If you export it, you're allowed to do something like this. Destructure here and say RPC endpoint. Oh, I think it's underscore endpoint. Yep, and then you can see the auto import. Go ahead and click that, or write it out like this. And now that endpoint is successfully imported into our underscore app. All right, so that's not all that we need to do. We need to import a lot of other things, such as the Solana wallet modules. So I'm gonna go ahead and do that. Let's import the connection provider. So I'll say connection provider, and you can see this is coming from our module Solana wallet adapter React, right? So all these modules are already installed if you did it with our CLI tool. If you didn't use our CLI tool, go ahead and do yarn add this right here. Cool. And there's actually another thing that we need to get from Solana wallet adapter React, which is going to be a wallet provider. Okay, so we need to provide the connection, and then we need to provide the wallet. This is how you can look at these imports. And it's cool because, again, Solana modules are helping us make it a lot easier for us. So what we can do is another import. Okay. If you remember in any other videos, when I click on the connect wallet button, you should see a nice modal that comes up that shows the different wallets, right? I didn't make that myself. You actually can get that provided for you from Solana as well. So you can say wallet modal provider right here. And you can see this is the module that it comes with. So Solana wallet adapter React UI. Cool. And then the next thing, we're going to say import, and I want to say enter here because there could be a bunch of imports that you'd want, but you can do a phantom wallet adapter. And if you want to add more wallets, put more options for the users, you can add all the wallets here. There's a couple different other adapters that Solana provides. And you can get this from at Solana wallet adapter -wallets right here. Okay, so once you do that, that should be it for wallets. We can do import this last thing, which is the CSS. So you can say Solana wallet adapter React UI, and then the /styles.css, right? Because if you don't have this, we're gonna have a really blank phantom or connect wallet button rather. Okay, so all of our actors are set. Now let's put it together. Cool. So one thing we're going to do is we've imported use state from React, right? That was given to you. What we need to do is make the state for something called mounted. Okay. All right. So to set up a state, you're just going to say const mounted and then set mounted. And we're just going to equal that to use state. And the default for this is actually going to be false. Okay, cool. Hit save. And the next thing we want to do is let's set up all the wallets that we're going to use. And like I said, it's just going to be one. So make a variable called wallets and set it equal to use memo, right? And then to use memo, it's going to take in an arrow function and then put this array here. And then you're going to say new and let's use all our imports. So the first thing that we're going to use is this phantom wallet adapter. So we're going to make a new instance of this adapter, hit comma, and that's it, right? That's it for this variable. I'm going to hit save. After this array, it does need a dependency module, so just do this. Cool. All right. And let's set up a use effect, right? Because there is this SSR error with next. So I just want to set up a use effect right here. Boom, boom. And then here we can set mounted to true. Okay, and again, let's add another dependency module right there. Cool. All right, so if you didn't know, in line 28, this component with ... page props, this is what represents our index.js, right? So what we need to do is wrap all of our providers around our app, right? Or our index. So the first thing we can do is at the top say connection provider, like so, right? If you're wondering where am I getting this? Well, we imported it right here. Now it's not grayed out. And what we could do is essentially just put it and wrap it like this. So now our connection provider, oops, sorry about that, but as I was saying, what we did there is we wrapped our app with this provider, and we're gonna do the same thing with the wallet provider, right? So how it should go, it should be the connection provider on the top, and inside that is the wallet provider, and inside that is the modal provider. Okay, makes sense? So enter right here and just say wallet provider. Okay, and I'm gonna close it and then take this and put it right here, right? Make sure that this closing wallet provider isn't under connection, right? Because this is nested. Okay, and from there, one more, we're going to hit enter and hit this curly bracket, right? So we can use some JSX. And what we want to do here is essentially say mounted and, right? So where's my and button? Right, so this means if this is true, right, then we can load our app, right? Because then we know that it's mounted and put the component inside of that. Okay, cool. And actually above that is the wallet modal provider, so we can say wallet modal provider. Amazing. So this is how it should look. Connection, wallet modal, and then this mounted check right here. It wants to make sure this is true, and then we'll load the index. Okay, cool. And this will automatically become true because the use effect is going to run this right when the app or this app.js component loads. Okay, and the next thing we should do is let's put in a couple different properties, right? So in this connection provider, the opening tag, if you hit enter, it has a prop or attribute called endpoint, and it's going to take in an endpoint that we use. So we're going to use our RPC endpoint, right? So now it's coming into play. Essentially, it's going to be what it looks like underneath the hood is quotes and then your long link that you have. So we have that stored in the variable, so we can just write this. Okay, and next it should take in this config, and it's going to be equal to object commitment, and you're going to say confirmed. Awesome. One more thing, it's going to be the wallet provider. We need to provide this with the wallets that we set up, which we did with this variable. All right, so kind of like the endpoint, you're just going to go into the opening tag of this, hit enter, okay, hit enter, and then do wallets is equal to, well, wallets, because that's what we call it. Okay, awesome. And then there's another cool thing that we have built in, which is the auto connect, right? So when you're already logged into your Phantom, it'll automatically connect that wallet to your app if it's been connected before. So this is a cool feature to have. If you don't want this, you don't have to have it. Alrighty. That said, we got our wallet set up, right? So how do we start using it? Well, we have to figure out where we want to add this connection. So if I go quickly back to my app and I ask you guys, what component is going to be holding this connect wallet button, right? Well, if you ask me, I think it's going to be what we have as the header component. So go into your components. It's nice and organized for you guys. Click on header.js and let's scroll to line 35. Right there it is, the connect wallet button. So what can we do to start using the wallet that Solana provides for us? We can just import it, right? So we can say import, and it's called wallet multi-button, like so. See this? All right, hit save. What we can do now is remove this whole div and just use that very component, wallet multi-button. Okay. All right, so with that said, let's take a look. So I'm gonna go look into here and look at that. There's my wallet, and I've connected this before, but this is what it would look like initially, right? So I can hit refresh. If If you want to see the full process, you can hit select wallet and bam. All right. If you want to give it more styling, because it does look a little small, right, what we could do is I have styling ready, and I think it's called menu item, right? I give it that same styling. So all you need to do is just put class name is equal to styles dot menu item. So hit save there, and bam, right? It's not so small and tiny anymore, and it has that nice hover effect. So don't be afraid. If you don't want to use the default CSS styling of the button, you can give it a custom one to match your theme. So there you go. We're connected, guys. This is it. That's how you set up your Phantom connection. Let's move on to the next step. Alrighty, so with that out of the way, let's get to the main part of the video. I X'd out the quick node tab, so if you don't need it, go ahead and get rid of it. What we need to do is head over to sol.pg, or rather beta.sol.pg. Or if you don't know what this is a browser where you can write your very own Solana smart contract. Usually we can use VS Code and create our Anchor project here, but this is a nice tool that lets us test functions, create functions, and everything we need without downloading all the files that we usually do. So if you've seen our other tutorials, this is what we've been using. So I can see this is our lib.rs, our Anchor file, and each of these is part of the program. This is called the account struct, right? And every single function like this one right here, initialize, is gonna have a struct that goes with it. So let's get started. The first thing we're gonna do is let's create a new project actually. And as you can see, there's 3 different types of frameworks: native Rust, Anchor, which is a framework of Rust, and then now it supports Seahorse Python. So if you wanna see us use Seahorse, follow the Instagram tutorial where I use Python for that build. So what we're gonna do is write prediction, right, dap, and hit create. Oh, and select the framework. Bam, cool. So nothing should change, right? This is pretty much the app, but let's go ahead and erase everything and start from scratch. And before we move any further, let's figure out what are we trying to do with this Solana smart contract. Well, what do we know? And this is called pseudocode. So what I'm gonna do is say prediction dap, right? And the goal of this smart contract is what? Right, we need to get the price of the stock using the Pyth network, right? Or Pyth. And then the functionality of it, because we can easily just get the price of the stock using this with the key. But the fun part about this is that we're making it so that users can bet on if the stock is going to go high or low and during a certain amount of time. So what we need is player A to choose an asset that's available in Pyth, right? So that makes sense. And inputs the length of the bet, right? Because that user should select something like AMC stock and say like, hey, within the next 2 minutes, let's see if the price is gonna go up or down. Okay, so that's player A. And this is important because if we don't know how the logic works, we might get into some trouble. So this is for us to understand. If you feel like you understand this and you just want to see me code, just skip a little bit ahead in the video and let's keep on going. But player B though, well, other players can see all existing bets. So after the bet is created, all right? So this is basically creating a bet. Create bet. Can see all existing bets, right? So how does that work? Well, we're gonna be able to fetch the bets, right? And then after that, player B can match any bets. So what does match mean to you guys? So matching a bet, let's say I create a bet over here and I bet 2 Sol that AMC is gonna go up in 2 minutes, right? Player B will also bet 2 Sol that could go down or go even higher, right? So that's why it's gonna match any bet bets and inputs his own prediction. Okay, does that make sense? Good? Awesome. So another thing is if the timing is over, whoever is closest to the price can claim the whole amount, right? So if player one or player A bets 2 Sol, player B matches that with another 2 Sol, what's the total price that they get after winning? It's gonna be 4, right? So again, logic is very similar to the lottery bet, except we're actually inputting our predictions here instead of just a random or semi-random algorithm. Cool. Alrighty, cool. So that should be enough pseudocode for now. Let's get to coding. And one of the first things we need to do is import anchor lang into our project, right? So usually in JavaScript, you've seen like import anchor from whatever, right? But we are on Rust right now, or rather anchor. So to import it in Rust, you just say use, right? And you can see this little suggestion, this helpful input, right? You're gonna literally say use anchor underscore lang, and then colon, right? You can think of colon like us going into a folder, right? We're gonna cd into anchor lang, and if we do this, we can destructure what we want inside of anchor lang. So what do I want inside of anchor lang? Well, there's gonna be something called prelude, right? And if I do a colon here, what does that mean? We're going inside prelude, exactly. So you guys are getting it, right? So what I want inside prelude is gonna be a star or an asterisk. This means I want everything inside of prelude, right? And then if you put a comma here, we're gonna get something else that's inside. Is it gonna be prelude or anchor lang? You got it. It's gonna be inside of anchor lang. We can get something called system underscore program, right? And another key thing about anchor is make sure you put semicolons, right? Semicolons mark the end of the line in code. In JavaScript, it's not like that, and you don't need to put it, but here we do. So if you see any errors, it's probably because you missed a semicolon. So now the important thing that we need to import is we need to be able to get the price of the stock using the network, right? So what we could do is say pith underscore SDK underscore Solana, right? The Pith network has an SDK that we can use in our Solana program to load the price feed into our smart contract, right? So we can get that by going into it, right? And we don't need to destructure it. We can say load price underscore feed from underscore account underscore info, and then semicolon, right? Don't worry about memorizing a lot of this. For me, I had to read a lot of documentation, test some code, and I was like, oh, okay, this is what we need, right? Cool. So we are using that library, and the next thing we should do is we should have the declare ID. All right, so, declare ID, and I hit enter, and it looks like this, right? This is going to be where our, the program key of our app is going to be, right? Which essentially is the key to access this program on the Solana blockchain. So for now, you can just put empty quotes, because when we press this build button, it's gonna generate that public key for us. All right, think of it as the address of this program on the Solana chain. Okay, cool. And the next thing we need to do is use this program macro. So you do hashtag and write program, because everything underneath this is going to represent the program, right? So then right underneath it, if you hit enter, say mod prediction underscore dap, right? This is the name of the program, right? Which we also have right here, okay? So if you want to change the name of your Solana smart contract, like on chain, change this, right? Next thing you can do is put these curly brackets, and everything within these curly brackets represents the program, right? That's the code block. Okay, cool. And now that you guys made the program, what you write in between these curly brackets is all the functionality, right? So this should be familiar to you, right? How do we make a function in Anchor, right? So to make it, I would just say pub, right? Public, fn, and then the function name. So if you open up the default version of beta-sol.pg, you would see something like initialize, right? We need to initialize our app in here. So this is a function called initialize. What do we need for this prediction dApp? Well, we need to do something called creating the master. So let's call that create underscore master, right? Because before we can create bets, right, and have player A, player B, we need to set up what's called a master account that's gonna hold the information of our program and, you know, all the functionality, okay? So how do we make the rest of the skeleton of the function? We're just gonna say arrow here, and then you're gonna say result, right? Boom, and then open and close it, and then parentheses inside of there, and put these curly brackets in there, and that's it. This is the skeleton of a function in Anchor, right? See this? So function name, right? This is basically the result, and then curly brackets to put the scope of it. Got it? Okay, cool. So what's next? Now, usually when you're making a function in Anchor, you have to create what's called a struct that goes along with it. So we need to make the master struct. So usually you can do it right here, but what we could do is just make another file, right? So go to right here under source, and we should be able to make another file. Let's create, let's go here, new file, there we go. And this new file, we can call it state.rs, right? Make sure it's rs. And in this file, we'll hold all of our structs that go along with our function, right? I've done it before where you put it all inside of the program, right? But the idea is to organize it and split it to files and then import the states into our program, okay? So I'm just gonna make a state.rs, right? So go ahead and do that. And once you do that, we can use anchor lang colon prelude colon star and then semicolon. Nice, cool. So make sure you're using anchor lang, and we're getting prelude. And how do we set up the struct for creating the master, right? So the first thing you have to do is use this macro called account, right? Because these structs, they're essentially opening up what we call accounts on Solana. The closest thing I could think of to help you understand it is that think of it as a object that you're creating on the Solana blockchain. And anytime you put stuff on the Solana blockchain, it's gonna cost some SOL, right? You're gonna pay for the space that you're using depending on the size. So what we're doing here is we're creating the struct of the master account. Like, what does that master object look like? What kind of properties does it have, right? So to start doing that, you do the hashtag account. Then you can say pub struct master, right? Okay, and after that, we can define what is the master, right? This is gonna make more sense to you if we make the bet, but think about the reason we need the master is because we wanna keep track of the last bet ID, right? So that every time we make a new bet, we can just increment the master so we know how many bets exist. So we could say pub last underscore bet underscore ID and then colon, right? Another thing that you need to know about Rust is that it needs to know the type of this, like that it's expecting, right? So you say unsigned integer, and then 64 is how many bits or bytes is this gonna be the limit, right, of the ID. So it's gonna be 64. And with that said, that's it. That's it for the master, right? But at this moment, right now, this master does not exist in the lib. So how do we make it exist in the lib.rs, right? You guessed it, we need to import it, right? So the way we import stuff, you can go up top here and you can say mod and then say the name of the file, state, right? Oops. And then afterwards, we're not done yet, we have to use crate, right? So what is use crate? Crates in Anchor is kind of like package.json, right? It's the equivalent. So you can say crate, use crate, colon, and inside of the crate, we want to get a couple things. And right now, we just want to get state, right? And remember what this means? Get me everything inside of this state, right? So essentially, we are bringing everything inside of this state into the top level of our lib.rs, right? So in order to use it in here, we have to do something like state dot or whatever. But if you just want to just use it straight up, we can do something called use super, right? So at the top right here, line 20 for me, you can say use super colon star and then semicolon. And don't forget to put the semicolon after the use crate as well. Boom. Cool. So what does use super do? It's going to bring everything in the top level of your lib into the program, so you don't have to do state dot or state whatever, right? You can just straight up use this master struct that we created. Okay. Awesome. And I will just put this comma here because it's nicer. All right. Looks pretty good to me. So next thing we gotta do is inside of this program here, we have to create the struct for create master. Like I said, for every function, you need to have a struct with the same name. All right, like that's the case like most of the time. So I'm gonna go into line 25 for me, make some space, and let's get started on that. All right, so what can we do to get started? Well, what I would probably do is go into here, start up a macro, and this one is gonna be called derive accounts, right? So we're gonna use accounts, right? When we're defining the struct of create master. So we can say pub struct, right? Anything under here is gonna be using this. So we're gonna do pub struct create master, right? And then give it a lifetime variable of info, right? Which has one apostrophe in front of it. Basically, a lifetime variable lets you know how long does this struct live in this smart contract, right? With Anchor and Rust, essentially, it needs to know how big everything is, how long everything will last, so that you can manage your space really well. Like in JavaScript, we're kind of they hold our hand in JavaScript because they have a garbage collector that collects the unused variables that we don't use. Anchor, you got to do it all yourself. Anyways, after you create the name of the struct, you add this lifetime variable info, right? You just want to go ahead and have this account macro here and put parentheses, right? And it's we have to initialize the account. So it's going to say init account here, right? So let me just do it manually first. And what you want to do is inside this parentheses, you say init, and you're going to say payer, who's going to pay for the space of this account, and the payer should equal the payer, right? And then comma, the space is going to be 8, which is how big this is going to be. It's just going to be 8, and then after that you're going to say plus 8. So this second 8 is what we call the account discriminator, right? How much space this account takes. There's always going to be an account discriminator, which you can think of it as the spacing between all the accounts in your program. Okay, cool. And then we have something called the seeds, right? So what are the seeds, right? Essentially, seeds are what the struct takes in, which is going to help generate a unique public key for this account, right? Because after a while, when we build this app, we're going to get a string of numbers and letters that's going to showcase the address of where our program lives. Every account is also going to have a public key associated, and it's going to be dependent on the seeds, right? So let's say it's inside the seeds, it's going to take in the string master, right? So we don't have that yet, so let's just leave that blank for now. Let's finish writing the rest of it. We're going to say bump, and I'll explain that in a second as well. But in line 35, after the end of the macro, hit enter, and you're going to say pub master, right? And what does this master mean? This is the account itself, right? So this is the account macro. This is the account that we're talking about, right? I'm talking about the master account. And what is the master account, guys? Come on. You made it right here. The master object itself with this ID. All right, so that means we want the create master struct to be aware of the master account. So that's why we're doing this right here. So how do we get this state? All right, we can just say account, right? Get the account, give it info, comma, and then say the name of the account, which is going to be master. Okay, cool. And what other information do we want in this struct? Well, it's going to be the account mute. This is where we're going to get the payer, right? So we're going to say pub payer, right? Because when we said payer equals payer, at the moment you don't know who that is, right? Well, payer is going to be the signer, right? Whoever signs the transaction. And you might be thinking, Lance, when did you write signer? We didn't make that in our state. Well, guess what? Signer comes from prelude. Yeah? So again, this is stuff that you can do by reading a lot of the documentation. I'm just simplifying it in my explanations if this is your first time. Okay, amazing. So the pair now exists, right? We're good to go on that. And the last thing is we always have to put the system_program. And this is going to be the type of program, right? So this is just defining what type to expect from this. So master is an account, payer is the signer, system program is coming from program. And then again, info system. Okay, which is coming from another library that we're importing at the top. Okay, well, believe it or not, this is it. This is the create master struct. We just need to put in the seeds, right? So what I'll do is create another file. And this one I'm going to be calling constants, constants.rs. And this is where we're going to hold all of our variables, our constant variables, right? And again, another way to do this is putting it all at the top here. But we could just make a constants.rs. All right, so what I'll do first is say use anchor prelude. Right, there you go. And we don't necessarily want everything, but let's see. We can leave this for now. All right, we're gonna add more to it later. But let's say our first variable is gonna be pub const. And remember, this is for the seeds. We'll say master underscore seed colon. And what type is the master seed? Well, it's gonna be and brackets u8 is equal to b. Well, make sure you do b quotes master. All right, this is essentially a binary string, right? Cool. And we want to take this binary string and put it into our seeds. All right, so bear with me for a second. So that should be it. But make sure you put not a comma, put a semicolon. And we're going to be adding to this every single time as we go through the app. And let's get imported our constant. So, you know, if you want to test yourself, try pausing the video and see if you can get the constants.rs into your lib.rs. Awesome. So if you tried it, the answer is you need to put mod right here. And it doesn't really matter what order you do it, but you can just say constants, and then you can put a semicolon. Okay, and then in your crates, you can do a comma and say constants, colon, and get everything from constants. Even though there's one thing, we're gonna get more later. So constant state, boom. So now we can just use it directly onto here. And instead of just getting, you know, like saying constants and then getting master seed, right? We can just say master seed, right? Okay. All right, so like I said, just write master seed. All right, me doing this is almost the same thing as writing a binary string master inside of the seeds, okay? But we want this one because that's gonna hold the variable. All right, so now for my explanation, what the hell is the seeds lance? Well, you could think of it like this. I'm gonna use something called a dice bear, right? Which generates an avatar based on your seed, right? Seeds in what's called Solana is a little bit different, right? I'm not gonna go over like how it works exactly, but the way that I understand it, you can go into here, right? Depending on what you write as your seed, we'll get a unique avatar. That's how dice bear works. So if I write master here, this is my avatar when I put in master as a string in a seed, right? So it's the same idea with Solana. If I put the master seed here, it's gonna, instead of generating an avatar, it's gonna generate a public key for my master account, right? So let's do a little diagram, right? Let's say this is our app and this is the Solana blockchain, Solana, right? My app is going to create an account or a master account. And what it does is it's gonna create some space in here. And this is gonna be the master account, right? And this master account is gonna have a unique public key. So it's gonna be something like this, right? Well, there's not those special characters, but it's gonna be a random set of letters, numbers, or whatever. And this is gonna be essentially the address of this account. So when I go to fetch it, right, I just type this in my app and I'll be able to fetch that master based on the public key, right? So that's why we need to generate a unique public key. We have to put in the seed, right? And this bump right here, let's say there's already something that exists with this public key. Bump is going to essentially go to the next available public key, right? So you can imagine this like, oh, there's already something that exists with master. Let's write master one, and this is our unique avatar or our unique public key. Hopefully that made sense, right? essentially, let's generate a new public key, and if it's not available, bump it. Cool. And then from there, we can test it by building, right? There might be an error, but let's just see if it works. Cannot compile. Unused imports constants. Oh, okay. I see. All right, so we got that error. I think, oh yeah, we need to add commas here, right? Can't forget that. And the last thing we should probably do is finish up our function. So the only thing we need to do with create master, right? The struct handles it already, right? In the struct, we're initializing the account, so we don't have to write any new functionality for that. Anchor is handling that for us. So what let's do is just say okay, right? It's an enum, basically saying like we're done, it's successful, right? Okay. All right, so now let's try to build. There is a error, custom attribute panicked. Oh man, how could I forget? I think I know the reason why. The reason is because if you look in here, the function, it needs to take in what we call context, right? And usually to do that, you just write ctx for context. And if it's unused in the function, you have to put underscore. And now what is the type of the context? What is context? Well, usually, like I said, when you create a function, you have to create a struct with a similar name, right? Because what you want to do is bring in all of this into the function. So you could just say the type of this is context, and inside of it, it's going to have the create master struct. Okay. And boom, this is like our return, the result. And then we'll do a building. Come on. Let's go. Build successful, guys. So that's it. That's how you create a master, your very first function on the Solana smart contract. All right. So the next thing you want to do is go ahead and deploy the app. And you might need some Solana to do so, right? So if you need more Solana on your app, you're just going to say Solana airdrop 2. Right? Cool. It says success, internal error. That's fine. Sometimes it does that. You just have to wait a bit and you should get some SOL. But I think I have enough because there's not much in our program. I'm gonna go ahead and hit deploy. And once it's deployed, right, we're essentially taking our smart contract and this is our smart contract. It's going to be deployed onto the Solana blockchain, right? So that's why we have to pay some SOL, and luckily it's not real, right? So we can deploy as much as we want, and then later on we need to fetch that program into our app. Okay, so that's the idea. All right, so I'll just check back in when it's done. Hey, let's go. Deployment successful, right? And as you can see, we lost 3 SOL for that deployment. Anyways, so now that it's deployed, we can go ahead and test our functions and see if they worked, right? So let me show you guys how to test your function. So anything that says instruction, that's your function. And now this is also the accounts, as you can see here, that we created. So if I asked you guys, do we have any master accounts that we created? No, we have none. And it comes in an array, so keep that in mind. So how do we create a master? Well, we can test that function right here without even connecting our app, which is awesome. So first thing we need is the master public key, and we can generate this from seed. So what did we put in here, right? Remember, in our constants, we have a binary string called master. You don't have to write a binary anything here. You could just say master for this, and it interprets it. And the program ID is going to be there by default. Hit generate. And the payer, right? Who did we say the payer is, guys? The payer is payer, or in other words, the signer, right? So we can say my address because I'm the payer. So now, if you don't have any Solana, you should probably get some now, but it doesn't usually cost much to create this. And I know that because it's only 64 bytes. So let's go ahead and hit test. Let's go, test pass, creating the master. So now if I fetch all, we can see that this master has this address, right? So to visually show you guys, this master has this public key as the address, right? And it has the traits of the account that we gave. So it has the last bet ID. Okay, so what do we want to do with this? Every time we make a bet, we have to go into our master account here and update it with +1, right? So once we do that, our last bet ID will be 1. So keep that in mind. This is the master. I'm glad the test passed. What's next? All right, so if you understood everything that just happened, you essentially finished the tutorial. Let's move on to the bet account itself. Okay, so what we need to look at, right, we don't need to see this that much anymore. We need to look at is creating a function, guys. So how do we create a function inside of this app? All right, we can say pub fn create underscore bet, right? And how does the skeleton look like? It's going to be parentheses, arrow, result, like this, and then so the curly brackets like so. And another thing I'll do is I'll move this struct outside of the program because it doesn't need to be there, right? And let's see if it builds still. Well, it might not build because we actually didn't finish writing the function. So I'm gonna just take it out temporarily or comment it out. Is this still acceptable? Yes, okay, so this is acceptable still. And we updated our build. Now, let's continue writing our function. So we made the function. What else do we need to do? We need to create a struct that also has this function. So the struct that has this function is called createBet, right? And what should createBet do, right? What should createBet do? It should create a bet account, right? So we want to create a bet account. First, we have to define what a bet account is. So I'm going to stop doing that and go to state.rs and let's create a bet account. So to start creating or defining an account, right, we can say attribute account, and then you can say pub struct bet. Okay, that's all you have to do. And then after that, you have to identify what goes into a bet. So what are the attributes of a bet? If you guys made classes before in JavaScript, this is essentially making a class. So every bet should have what? Should have an ID, right? And what should be the type of an ID? An unsigned integer 64, kind of like this, right? And we can use the master to define what the ID is, right? What's the last one? Plus one of that. There you go. It's the new ID. Okay. Next is we need the pub amount, right? How much is the bet worth, right? How much does it cost? And another thing is usually we talk about it in Sol. When you're in the Solana smart contract, it's going to be in what we call lamports, right? Which is a smaller unit of Sol. So if you think about $1, a cent is what lamports are essentially. Okay. The next thing we need is pub prediction underscore A, right? This is essentially the prediction of player A. And the type of this is going to be pretty interesting, right? It's going to be something else that we call a bet prediction, right? And I'll explain that later. Bet prediction. Like so. Cool. And then next we need pub prediction B, right? And it's not going to be the same thing, right? Because there's going to be an option, right? Because by default, when you create a bet, you're always going to be prediction A. That's always going to exist. But when you're creating a bet, player B doesn't exist yet. So it should be null at first. So that's why we're going to say option. And then inside of that, we'll put bet prediction. Okay. And then after that, we should have the state, right? And by state, I just mean, what is the current state of this bet? Was it just created? Did the bet start? Did somebody win, right? That's going to be controlled by something called a bet state. And we're going to be defining what this is, and this is just a bit. Last but not least, we need the Pyth price key, right? The pub Pyth or Pyth price key. And that's going to be a public key. And you can simplify it by writing pub key. So what is Pyth price key? Well, we're going to be using the what's it called? The Pyth network. So what we can do is make a new tab and say Pyth network. Right? And essentially they're going to get real-time data from real world markets, as it says here. And if you look, there's many different stocks and crypto that's keeping track of. And if you, let's go ahead and click AMC, you can see that it's fluctuating between its price, and you can see from the graph here, it's at 3.89 right now, right? And you can see all the transactions where it's updating that price, and it's pretty fast. It's going to be from 2 seconds to 2 minutes. And to get the price, or to know what the price is, you need this public key right here. This is called the price key. And the cool thing is that you should understand what this is now, because this public key is going to go to the account in the Solana chain that holds the price, which is like 3.8, right? And this account constantly gets updated over and over again, right? Over and over within that time frame. So it's always going to know, right? It's real time of the stock of AMC. Okay, and to utilize that, right, that's why we're using the SDK, right? We also need the public key stored into that bet itself, right? So we know which one to look for. All right. The last thing we need is something called the timestamp, right? We need to know how long is this bet gonna last for. It's gonna last for 1 minute, 2 minutes, 5 months, right? So we need to say expiry underscore TS colon, and then you can say I64. This is different than U64. It's a signed integer and comma. Okay, so I'm just gonna add comments really quickly so that you understand what and remember what each of these are. There we go. So I'll just pause to take a moment and write some comments for you guys so you can understand. So pause the video if you want to take a look and add these yourself, but essentially it's what I explained as I was typing. Okay, cool. Up next, we need to define bet prediction. So I'm gonna come down below here, and we need to write something like this: derive, and then we need anchor serialize and to deserialize. And it should be coming from Prelude as well. And then there's last thing called clone, because we need to add some more attributes, or I guess properties, inside of this prediction A, right? Because prediction A is gonna have a struct called bet prediction, right? And this is also going to be inside prediction B. The goal with this is to store the player, right? So you say pub player, and that's gonna have a public key, right? This is gonna be the wallet essentially that's playing. So your wallet, if you remember, has a public key, right? And my public key is this 8TKZ, right? Okay, so that's done. Another thing is it needs to know the price, right? The price prediction, right? What did I predict that it would be, right? And I want to use this, right, inside B as well. So I'm going to reuse bet prediction, right, and give it an option, because the option can be none or it can be these. Okay. And then this is the, so if I write comments, this is the price prediction in USD, and of course this is just the address that bets, right? It could be player A or player B. And then after that, we need to make another one. This is for the bet state, right? Because it's going to be different things, and we need to serialize it and deserialize it again. So anchor serialize, comma, anchor, deserialize, clone, and then there's a partial EQ that we need. Okay, because this is going to be an enum, right? So pub enum bet state, and again it's going to be created, started, what's another one, player A1, then it's also player B1, and then there could be a draw where they both somehow guess the same exact price. Not likely, but it could happen. Okay, so there's created, started, player A, player B, and draw, right? There's actually a lot of logic that goes into this. I did simplify it so that you can get just a better understanding. So keep that in mind, and that should be it. So believe it or not, all this states should be done unless we need any more later, but I feel pretty good about this. So that state is done. Now let's finish the create bet struct. All right, so I'm here at the create bet struct, right, at the lib.rs, and what we need to do is just derive accounts again. So we're gonna say derive accounts like that, and then just say pub struct create bet, right? As you can see, it's similar to create master, and even the info part is going to be the same. Okay, put the curly brackets to identify the scope, and next let's initialize the account. So again, Anchor has a way to initialize the account already. Oops. And you can initialize it by literally writing it in. Now it's done, it's initialized, right? Next you have to define who's paying for this. You guys should know it's going to be the payer, which we'll define later. Next is how much space it needs, right? So we need to essentially figure out how much space does a bet need, and depending on the type, right, we need to tell him, all right, it's this plus this plus this plus this, right? You can find this out by looking in the Anchor documentation, how much is each thing. But I can tell you already, it's going to be 8 plus 8 plus 32 plus 8 plus 8 plus 32 plus 8 plus 1 plus 32 plus 8 plus 1. And let me just double check this is it. Yep, that looks good to me. Let's put a little space here. Yep, this takes a lot of space because the bet has a lot of information, right? It even has some more properties within that. Okay. So that is the account initialization. We just have to put the account right underneath that. So we can say the pub bet colon is account, right? And what is the account? Well, first you got to put the lifetime variable of info, and then you can say the account is bet. Cool. Next, we need this struct should also have, in the context when we bring it in, it should know about the master account. So we need to get the master account. So we don't need to initialize it, keep that in mind. We just need to get it. So yeah, I might add a comma here. There you go, now it's the correct color. We say account, and instead of saying init, we want to say mute because it can change. We say seeds is equal to master seed. So what did we do here? We're getting an account with this seed, right? And again, if it already exists, we'll just bump. There, cool. Pub master is going to be the account info, comma master, right? So there we go. We're able to pull the master account by doing this. Next is going to be the player account, right? We need the player. So actually I named this player now. Same thing, it's gonna be the exact same thing. Account is mute, because there can be different players here, and you're just gonna write pub player. So now this is defined, but what type is this? It's just like before, it just has a different name, guys. It's gonna be signer with info. Okay, and I should keep forgetting to add these commas. There you go. And last but not least, the pub system program, and we can pull program from there. A lot of Anchor code is just repeating. It's like boilerplate. So once you get the pattern, it's going to be easier for you to create whatever smart contracts you want. So that is the create bet struct. Okay, now for the functionality of create bet. So what does that need to do? Well, create bet needs to do a couple things. The first thing is needs to take in the context. So to get the context, and this is actually gonna take a couple of things. You can say ctx, right? Comma. You can say amount. When you create a bet, what else do you need? You need the price prediction, right? Duration, and the pith price key, or pyth price key. I don't know how to say it. Price key. Okay, cool, and then close it off. Next, you have to put the type of it, right? So the context is going to be context, and the context is going to be the create bet struct. The amount, right? How much are we betting is U64. What is the price prediction? Remember, it's going to be in USD, so it's going to be F64. And then duration is going to be U32. And I always make a little comment here that this should be in seconds, right? Seconds. And then we have this, which is a pub key, right? This is the price key that we will get from here. And I've already hard-coded that into the code, so you don't need to pull it. Okay, next is the result. Right, so what is the actual logic of this function? Well, the first thing you need to do is increase the last ID on each bet creation on the master, right? So the master ID should be increased. And to get the master ID, right, we first have to make a variable called let master, right? This is normal, is equal to, and mute. So this is new, right? So we want to say that the whatever after this can change. It's not one static thing. Rust needs to know that, right? So if it does change, or if we do update it, it's gonna be ctx.accounts, right? So what's ctx? It's our context. Okay, what's in our context? All of these 2 accounts. So that means if I do dot accounts, I now have access to the bet account and the master account. So how do I get the master account from here? Right, think about what an object is. You just have to say dot master. Cool. And let's get the bet while we're here too. Is equal to and mute ctx.accounts.bet. Makes sense? Right? This is essentially the object, and we're getting the master from the accounts, and we also have the bet there. It all exists because we ourselves created the struct. Okay, so now we can do whatever we want. So like I said, how do we increase the last ID on the master? Well, this variable holds the account, so I can say master, right? And then if this is an object, what properties does it have? So we can even look at it here if it makes sense for you. It has last bet ID. So all we have to do, guys, right, is dot last bet underscore ID. And you can do plus equals 1, right? Just not scary code. Solana isn't scary, right? You just need to get used to the wording, the documentation, and why we do things, right? And again, I'm no expert, right? I just do this a couple times until I get it. I've had help, right? Ask questions on the Anchor Discord or the Solana Discord, and it'll help you get better at this. So keep doing this over and over. Watch this tutorial several times, and it'll make more sense. So then the bet ID is going to be the master last bet ID, right? Remember I told you, right? The bet ID is going to be whatever the master was plus 1. We already initialize it here, or update it rather, and we can just use that same variable here. Cool. And this will happen every time we want to create a bet, so it's pretty good logic here. And the next thing is the bet dot pith underscore price key or pyth key is going to be equal to this, right? The one that we passed into the argument, right? Because we're going to do that in the front end. Oops, sorry. Pyth or pith price key, and then don't forget the semicolon here. And then it's pretty straightforward. You just plug and play everything you wrote down. So it's going to be bet amount is equal to the amount I passed in, the bet dot expiry ts, right? This is the timestamp, and you need to do something like this function called get Unix timestamp, right? We're able to just get the current timestamp using this, and we got to add duration as I64 and then semicolon, right? Because what's happening is I'm saying the bet is going to take 150 seconds, which is like 2 minutes. It's going to take what's the timestamp now, and then add the 2 minutes, and that is when the bet expires and you can't enter anymore, right? Or else it's unfair. All right. And next is the bet dot prediction underscore a, right? We're actually going to define that the bet prediction, right, is the object here, and the player, right, because we define bet prediction as player, is going to be ctx. We need the public key of the player. We can get that by doing dot accounts dot player dot key, right, and then comma. And then from there we could say price, okay, and then semicolon here. after the bet prediction. And the last thing we have to do is we need to actually get the Solana from our Phantom wallet and put it into a third-party account or an escrow to hold that bet, right? So the idea is both players put money into the third-party account, and then when it's done, that third-party account will send the winner the total pot. Okay, so we're gonna use an escrow for this. So we can do this, and I'll just write a comment here: transfer the amount to the bet PDA. So we can say system underscore program transfer and say CPI context new. There you go. And that's exactly what we'll write. So we say CPI context. I'll go into that and say new. And this is how you, oops. Oh wow, okay, don't need that. Boom. All right, this is the how we go and transfer it. ctx.accounts.system underscore program dot, okay, oh sorry, dot to account, I think. To underscore account underscore info, and boom. Okay, so essentially we're putting that's the player's Solana into the bet PDA or the account. Okay, and here we can do the transfer. System program, let's get the transfer. Boom. And we're gonna get this from the player. So we do ctx.accounts.player .to underscore account info. Okay, and then we can do to, oops, bet. So we're taking the money, the SOL, putting it into the bet account, and once the bet's over, we'll give it to the winner. And we can comma here, put the bet dot amount. Okay, and there's some things we need to add like this. And of course, when the function is done, we're gonna hit OK. Okay, that's how you know it's done. That should be it for this. And now I'm just gonna run build. There might be some typo errors, or I might have spelled something wrong. So let's just see, do a check. Yep, there it is. Oh, there's a little M here. All right, it's insane with Rust because one error is gonna mess up the whole code. Let's do this one more time. I believe there's still more. Yep, forgot some semicolons. So let's go to where I wrote bet. Semicolon, semicolon. And then it says bet.expiry TS is unknown. Okay, let me just check the state. Oh, underscore TS, whoops. Where is that? Yeah, it should be bet.expiry underscore TS. Okay, and I think there was one more issue. It was CPI context. Oh, is it because I forgot the T? Let's see, build. Okay, cool. Now we need to fix the get Unix timestamp. Get Unix timestamp doesn't exist. Oh, right. Okay. I need to make one more file. It's going to be the utils, right? There's some functions that we need to create to make a lot of the code doable. Again, this is a pretty big program that I had to scale down. So if you do use anchored lang in here and get a couple things. Whoops. And we want to get prelude, of course. Prelude, colon, star, comma. We need Solana program clock, and then clock Unix timestamp. Okay. The main thing we want to do with this is create that get Unix timestamp function, right? Because it doesn't exist. So let's make it exist, and we can bring in our variables here because we're going to use them later. So let's do a use crate. Let's get constants, colon star, and also state colon star. So we can use them here. And what we want to do with this is create that function. So we need to make a function pub fn get Unix timestamp. So now it's going to exist. Boom. And we can do an arrow here. Yep. So now let's define a type of timestamp. Boom. And this is literally just going to pull the clock from the anchor program and unwrap it. And then we could store it. Unix timestamp. So this is what it returns. Get the timestamp at this current moment when it's run. And then we can just go to the lib. This should exist now because we need to import it. So to get this into our program, you say utils, you say comma, utils colon star, usuper brings it into this, and crossing my fingers, let's go. Still doesn't work. Oh, unexpected token. Okay, that error is usable. Expected a semicolon here. Can't forget those. And let's try again. Am I missing something? Unix timestamp not found in scope. That's weird. Should be in scope. Oh, anchor land. That's probably why. Yeah, so spelling is really important, guys. I messed that up a lot, but we should be better now. Warnings are okay. Use crate. Constants. Let's go. All right, cool. So again, none of it was the logic. It was just me putting semicolons and then the spelling. So build successful, right? We can go ahead and deploy this now, right? Yep. Let's hit build. And boom, right? One thing is that we can't really test this just yet because if you want to test it on Solana Playground, it uses the localhost, and we can't. It doesn't. This Pith network doesn't work with localhost, so I'm gonna have to transfer it into our app and then test it there. But that is essentially the create bet. All right. So with that out of the way, let's get to the next function. So the next function is going to be entering the bet, right? So what does entering the bet mean? It just means we should be able to participate in the bets that are already created, right? So we're not creating a brand new one. We are becoming, this is essentially player B's ticket to participate, right? So it's gonna be called enter bet, okay? And the arrow and then the result. All right, at this point, you guys should be picking up on the pattern to make the function, okay? And we know that this is gonna have CTX, and we know that it's gonna take in the price, right? This is player B's price prediction, okay? So what do we need to do when we enter the bet, guys? Well, we need to create the context, right? Or the struct that goes with entering the bet, okay? So let's go down here, create bet, and underneath this, enter the bet. So again, we first need to derive accounts. All right, so, whoops. I would ask you guys, do we need to initialize a bet account? Nope, we don't need to do that. We can just get the bet account. So we'll just say pub struct enter bet, and then put the info inside. Okay, and then from there, we can have the account. And again, we're not initializing it. We just need to get that account. So it can be, the bets that we enter can be different. So you want to make sure it's mutable. And we need these seeds. Oh, did I put a seed for the bet? I did not. All right, so that's one thing we need to remember. I put the space here, but so go back to your create bet struct, and we need to put the seeds in there. All right, otherwise it's not going to be able to create a new bet with the right public key. All right, so the seeds this takes in is going to be into state, or sorry, constants. And we're going to say pub, what should we call this? It should be, it can just be bet seed. So I'll say pub const bet seed, and it's going to be similar. It's going to be and u8, oops, is equal to binary string and say bet and semicolon. Cool. And this should be capital bet seed. Nice. So now we have that. It's already being imported. So now for the create bet, we're still back in create bet. We just want to say bet here, bet seed, not net seed, bet seed. Okay. There is one more thing that we need. We need to have the master's last ID, right? So this is different than last time, right? We have the binary string bet and the master's last ID. So if it was 0, this would be the public key. If the last ID was 1, 2, right? So it's unique every time depending on the last ID. Okay. So it's going to be and master.last bet ID. You can't just write master last bet ID because you need to format it like so, +1, and then you say dot to the bytes, because you have to convert this into bytes, because that's what the seeds need to read it. Okay, and then this should be come right here, boom. All right, so we'll check on if that give us any errors later on, but we also need to add bump, right? Because if it already exists, go to the next available public key. Cool. So now, and a good thing we did that, because now remember to get the, when we enter the bet, to get to the bet that we want, we need to get it by seeds. All right. So that's the purpose of seeds. You can also get the public key you want by putting in the matching seeds. All right. So to do that, we'll say bet seed, right? And just put in the bet ID, because the bet ID is the same as that last master bet ID. All right, the last one. So we'll do and bet.id, and we gotta convert this to bytes again. So .to le bytes, and then it's a method. There you go. All right, don't forget to add bump here. Then there is some constraints, some seed constraints. So we gotta say constraint is equal to validate enter underscore bet, and you say and asterisk bet. And you can say at bet error you can't enter, right? So basically, if there is already the bet is already entered, you cannot enter that bet. So this is an error, bet error, that we need to grab and create, and this is another thing in our utils function. Okay, so we'll come back to that in a second, but let's just write out the rest of this. It says pub bet, right? All of this information is in this bet, and what is the type of it? It's an account that already exists. It's info and bet. Cool. Next thing we need is going to be the player, right? So there's no account for player. It's just going to be stored as the signer, right? Pub player is the signer. Yep. And then the system program, right? We always need this one. System program is the program. And look at the system. Nice. Cool, cool. So that is the enter bet struct, right? We didn't have to make a new account. We do need to work on this part though. So remember, we got to check if player B is allowed to enter this bet, right? So we can go back to our utils. We're going to make a new function again. Say pub fn validate enter underscore bet, and it's going to take in the bet and bet, and it's going to be a boolean here. Okay, and essentially this is what we're going to return, a boolean, and we're going to get that boolean by saying bit prediction right? Underscore b dot is none. Okay. And then we can hit enter here, and I'll just say and. We gotta check for the expiration. So basically what I want to say is, let's say player A makes a bet for AMC, and he says it's gonna go up within 2 minutes, right? You can kind of cheat that bet, right? If you think about it, you can stare at this, and if there's like 2 seconds left, I want to say, oh, the price actually is 3.9, right? You'll have a more accurate guess if you bet later. So we should make an expiration time, right? So to make that expiration time, we can just head over to constants and make it, right? So let me just write that comment. The closer we are to the expiry, the more chances a player has to win, right? So we want to make an expiration time to make it more fair, right? We can add even more logic to like check for that, but again, this tutorial will be way too long. But if you do want to see that, comment down below and seeing like a full-on like full-scale build of a betting system. So let's go adjust this to make it more fair, right? So what I mean by that is we can say pub const, this is a really long variable, minimum remaining time until expiry, right? And to get this, you can use we're gonna need another library. Solana. Honestly, we don't even need Prelude here. It's gonna be unused, so let's actually get Solana program. Yeah, we need this library instead. Program, and from inside program there should be clock. And inside the clock there should be Unix timestamp. That's what we need. Yep. Okay. So then now we can say Unix timestamp here. Okay. Oh, sorry. And set this equal to 120 seconds, right? So the last 120 seconds, they can't enter the bet, right? We can adjust this to make it more fair. You can say like, oh, after 1 hour before the bet, you can't enter the bet anymore, right? So this is essentially like a minute. Okay. So then you can say pub const maximum claimable period, right? Since we're here, this one is for, let's say somebody wins, they should be able to claim the money, right? After a certain amount of time, the money will actually just go to the user, or be given back to the user, right? Cool. So maximum claimable period 300. Okay. So we have that. What we really care about though right now is this one right here. So let's go back to the lib and go back to our validate enter bet. And now that we made that variable and we're importing it here still, we can use it. So where was I again? Validate bet. We need the expiry. Can't forget the underscore and minus. All right. So the time that the bet expires minus the minimum remaining time until expiry. All right, there could be a better name, but this is what we got. Is greater than the get Unix timestamp. There we go. All right, so this is how we can validate if player B can enter the bet or not. All right, it's gonna be true or false. All right, that's what is running right here. So we're gonna have a constraint. We're gonna check, okay, can player B enter the bet? Yes. All right, if he can't, if it's false, then we need to run this error, this bet error, right? But right now, bet error doesn't exist, so we can make that error. So to make an error, we can have a file to have all of our errors. So we can say error.rs. And inside this is the one that's gonna use anchor prelude. So I'll hit, oops. Let's see if I can use their import here. Nice. And to set up your error codes, which you can do in Solana, is error underscore code, and then say pub enum bet error, like that. Okay. So next we can do hashtag array, oops, and and then just do message. Right, so we're gonna send a message, and it's gonna be cannot enter. Right, and the name of this error is going to be cannot enter. Right, so what's happening now is in here, the constraint of entering the bet is we check if this is true or false. If they can enter the bet, if it's false, there's gonna be an error, and the name of that specific error is the cannot enter one. Right, and one thing we should do is import error as well. So let's get mod error.rs, oops, sorry, error, and we need to put this in here as well. So comma error : star. Okay, I think we are good. We do need to finish up the rest of the the rest of the functionality of EnterBet. So let's go ahead and do that. So we finished the struct. We're on the functionality now. The context is the EnterBet struct. So we can add that right now. EnterBet. The price is something that we're going to input through the front end, and we say F64. Right, 'cause it's going to be in USD, right? Or like at least the decimal. So it's float 64, and let's get the bet into a variable. And we need something here, guys. Do you remember? Yes, exactly. Good job, Jeffrey. It's and mute ctx.accounts.bet. Okay. Bet.prediction_b is equal to, right? Because this is for the whole purpose of this function is for prediction b. And remember, prediction b, what is it again? It has state. It has bet prediction, and it starts off as an option, right? So we got to keep that in mind. And so it's going to equal to some bet prediction, and then kind of like how we set up the prediction A when creating a bet, you're going to do the same thing. So the player is going to be the player that's entering. So that's the ctx.accounts.player, and then we need their key. So that's how you get their key again. And then we need the price, right? So we're taking our argument and placing it here. Okay. And then we should update the bet state to equal the bet state of started, right? Where is this bet state started coming from, guys? All right, if you remember our state, we made that right here. It's an enum, which means it could either be created, started, or any of these. Cool, so the bet state is equal to started, right? We're not done yet though, because when you enter a bet, you gotta give us some SOL to enter, right? We're gonna match the price. So if it's 2 SOL, give me 2 SOL. So transfer the amount to the bet PDA once again. And then we do the system_program. Let's get the transfer in here, and let's run that. And we can say CPI context, so we won't forget the T this time. The new, and pass in these arguments, which is going to be the system program. So to get that is ctx.accounts.system program .to account_info. Okay, and then in there we're going to say system program transfer. Right, and so here we'll do the transfer. We need the from and to. So who is this from? This is from player B, which is the person signing. So we can say accounts.player.to account_info, and it's going to go to the bet PDA, right? So the bet account. So it's going to go to that bet account. Okay, comma here, right? Bet.amount. That goes the amount that goes in, and we do need this question mark, and there we go. Last thing we do need though is the okay, and boom. All right, this okay, if you don't know, you can think of it as a return. So if this function is all done and it's good, you can return like the number 5, right? I don't know why you do that, but you don't need to. We're gonna put nothing in here because all the functionality is happening right here. Okay, looks pretty good to me. That should be enter bet. Let's just build this and check for any errors, which is normal. Right. If there is a time that I never had errors, I get so happy. So prediction B is some bet. Okay, something wrong. It might be the spelling. Yeah, predict Cyton. Prediction B. And let's go. Build successful. Again, don't worry about all these warnings, right? You can build even though the warnings are here. It's just Anchor letting you know, like, hey, you wrote this, but you didn't use it, but we're all gonna use it eventually, right? So I'm just setting some stuff up. So build is done. That is enter bet. All right, so we have enter bet. Let's get started on claiming bet, right? Because what we have so far logic-wise is we can, create a bet, put duration and the price. Player B can now enter it, but now once the bet is over, we need a function that's gonna let us claim that said bet. So once again, how do we make a function? It's just pub fn and then the function name, right? From here, you need to put the parentheses for the argument, the arrow, and then result, boom. Okay, and then after that, curly brackets to put the scope. And the only thing that we're gonna need for the argument is gonna be ctx, right? And we're gonna define what the context type is in just a moment. All right, so the first thing we're gonna do is scroll down to the bottom right here, and let's find and create claim bet. All right, so we have enter bet right here, and then we need claim bet. All right, so claiming bet. How do we start this? All right, the first thing we need to do is get the accounts that are relevant for the function, right? So to derive accounts, we need to say derive accounts, right? And what accounts do you think we'll need for this bet, right? After I write the name. So as I'm writing this, think about that. Pub struct claim bet. Okay, and then we need this info here, info, and then curly brackets. All right, from there we can do the account that we need, and you guessed it, it's gonna be the bet account, right? So we don't want to initialize an account, so we don't need to write init here. We should write though mute, right? And then how do we get the specific bet that we need? We need to put in the seeds, right? So to put in the seeds, we're gonna do seed equals, seed equals, and then we have to say, I believe bet underscore seed, comma, and then we have to say the and bet dot id dot, and turn this into bytes. So do 2 underscore le bytes, and that is a method, so parentheses, boom, and that should give us the bet that we enter. And then bump, right? And then the constraint. So there is also a constraint here, compatero, right? Constraint. So what's the constraint here? Well, we need to validate the not the enter bet, the claimed bet. Like, can we claim this bet? That's what we need to validate. So we need to go back into our utils and let's create that function real quick. So I'm gonna go under here and say pub fn validate, right? This time the claim bet. Can we claim this bet, right? So there's two things we need to think about. One is this over, right? Is it expired? Is the bet expired? Can we still claim it? Is time not up yet? If it is up, we shouldn't be able to claim it, right? If the bet is 2 minutes long and it's only been 30 seconds, I can't claim this bet, right? You should get an error for that, which is like 6002, I believe. Okay, cool. So what we can do to check this is a match statement and say bet.state, right? If the bet.state, bet state, : started. And if you're wondering what bet state is, if you go back to our state.rs, we made bet prediction and we made bet state. So what are the couple different states we can have? Created, started, right? So which one do we need, right? So let's go back to our utils. So if the bet is started, right, what does that mean? Okay, then say equals arrow and then curly brackets. All right, so if the bet is started, let current timestamp or TS equal to get Unix timestamp. All right, get the current timestamp with this method. Okay, and set that to current TS. And don't forget the semicolons here. And what we need to check for is this variable. Let's say let time passed since expiry, right, is equal to the current time, so the current underscore TS minus when the bet expires, because the bet, that's another condition you think about. If the bet is expired, we shouldn't be able to claim it anymore. Expiry dots TS, underscore TS. Okay, and then if 0 is less than the timed past, expiry, and the time passed since expiry, that would mean it is less than or equal to, I wonder if I do this. Yeah, there you go. That's the symbol we need. Maximum claimable period, right? We're checking if this total statement is less than the claimable period, because if it is, we should still be able to claim it. If it's not, then this will return false, which means we cannot claim it, right? So that's what's happening here. We can do a comma, and then we have to do a dash, I believe, or underscore, and then do equals arrow false, and then comma. Cool. So that's how we can get it to be false. And then if that's false, then we get the Boolean false as well. Okay. All right, let's go. That's going to be the validate claim bet, which means we can come back to our lib.rs and then actually use that function we just created, which is going to be validate claim underscore bet. Okay, and then it should be like a and star bet, just like before up here. And the bet error that we want is cannot claim. So at bet error cannot claim. And let's make just sure we have that error. So check error.s. We do not have cannot claim, so we need to create it. All right, so we'll put a comma here. We need to put a message that says cannot claim. All right, so now it exists after we define it. Okay, and there's a couple different errors that we're gonna need. Since we're here and you get the idea, I'm gonna do the rest of them now. So let's do another message. This one's gonna be cannot close, right? Cannot close. Okay, there's a couple other error messages where it's gonna be like if you have an invalid pith key. So we can say given key for the Python account. I'm always saying the different way to say it. Does not match, right? So let's say you put in the Amazon stocks key, and then later you're trying to use Google. It's gonna know. It's gonna be like that's not the same one. So then you say invalid pith key. This will help us troubleshoot. Okay. Then there's another one. Message. There's also another invalid pith account, right? So we can say invalid pith account, and this doesn't need to be capital. Invalid pith account. This one has to be capital. Okay, one last one. I believe it's going to be the price is too big to parse, right? Because if you remember when you create a bet, you parsed it with U64, right? So if I go to state, yeah, U32. Right, so this is the limit of the space. So we don't want to do anything bigger than that. And just to be safe, we need to put it to 32. So we can say this error happens when price is too big to parse to U32, right? Even though that's the limit is U64, we don't want to hit that limit, right? So we can just say price too big. All right. Cool. So we might not use all these errors, but we're definitely going to use these three for sure. But this, if you want to add more unique errors for other situations, because there's a lot of logic in a fully functioning lottery app, make sure to add them here. So this is all the errors. And now back to the lib.rs. This bet cannot claim error is going to run now because it exists. And all I have to do is just put a comma here. And the whole point of this, the whole point of this was underneath this whole account information, we're gonna set up the bet. So we're gonna say pub bet, right? And the type is an account info and bet, and I'll put the apostrophe in a second. There we go. All right, we're good. And then a comma here, and then we need to set up the Pyth Oracle account, right? The Pyth price Oracle account. So we can say it like this, right? Because remember, each of these is an account as well. So there's an account for AMC, and it's going to contain a price, and in the back end, this is constantly updating to the latest price. So for here to get that account, we have to put parentheses and don't press init because that's making a new one. We're going to say the address of this account that we want is going to be the bet, right? Because now we have access to the bet account if in this struct. The bet dot account, bet dot pyth underscore price underscore key, and then there we go. All right, so how did we know that this is where the Pyth price key is? Well, if you go back to your state, there's a attribute or property where we store that, and it should be there after you create your bet, right? So you can say is equal to that, and then you can say at bet error, right? Because what does this do? It means that if there's an error here, it's probably because it's an invalid Pyth key. All right, so that's why we made those errors. And then from there, we can say pub pyth or pyth account info, boom. So essentially, get me the address of the bet.pyth price key, and if it's not the same, then we'll get the invalid one. Or it's not correct, it's gonna give you the invalid error. Okay, next thing we need to initialize is both players. So let's get their accounts as well, or the part of their accounts, which is gonna be account mute, and their address is equal to the bet.prediction underscore b dot as underscore ref dot unwrap, right? Because whenever you do this, you have to unwrap it, and then you get the player from that bet. Right, so we're going to the bet account, and if you remember, in the bet account there is a bet prediction here. There's two actually, one for A and one for B. So we need the one for A, right? So this is for B. So let's do one for A actually. I'll come back to that because that's for B. Now that I'm thinking about it. So we need account address is equal to, mute. This could be different. Address is equal to bet dot prediction, and how do we get A dot player. Yes, and then from here we could say pub player underscore A is equal to account info, right? Because we just want the info of this account, apostrophe, not quotes, info. Keep pressing that. Okay, info, there you go. Then the comma after here. Cool, so that's player A, and this is player B. And the reason why I did this for player B is because they are in an option. So we're gonna unwrap it first, then get the player. And then this one's gonna be pub player underscore B is equal to account info. What's going on? Pub player. Oh, it's not equal, sorry. Colon, account info, comma. Hey, there you go. Cool. And the next thing we need is the things that we always do every time we create a structure, which is identify the signer, who's signing this transaction, and the system program. So honestly, we could just copy this and paste it right here. And hit save. Oops, we don't have to save it like that. And then the player, right? This is gonna be confusing because there's two players. We can just change the name of this to signer. Signer and system program can stay the same. And with that said, that is the claim bet struct, right? So we have all the account information. We're accessing player A, player B within this struct. Let's bring that struct into our function, right? As context, and say context arrow claim bet And let's start working on the function itself. So this function has a lot of logic that goes into it, because not only does it need to run a couple checks, it needs to take the money, right, from that third-party escrow account, the bet account, to the winner. And that winner could be player A or player B. And we can also need to check for, can they even claim it? So let's go ahead and work on that function now. All right, so now we're working on claim bet. And what I want to do is write a couple comments so that we can identify each section. So the first thing that we should think about is check the winner and send the prize to the winner, or return them back if it's a draw, right? Because that's also a possibility, right? So how can we do that? Well, first, what we've done before was set a variable and set the account in that variable. So let's do the same thing again. So let's set the bet, right? It's a variable equal to and mute, right? And mute ctx, right? Our context argument. And from that object, you can get the accounts. And the account that we want is the bet. Awesome. Okay, cool. So we have the bet account. And what is the prize? Well, the prize is let prize is equal to, bet.amount.checked mul to dot unwrap. Okay. And then from there, we can do this right here. bet.toAccount, account info, under parentheses, dot try borrow, right? Try borrow mute lampworts, right? Is equal to the price. All right, this is important that we do this because we need to figure out how much the prize was. So we can do that by getting the bet amount, right? And then we can go into the bet accounts info and get all the lampworts that we put in there. We're going into the third party account and subtracting it by the prize, which should be the whole thing that's in there or that we put into there. And then from there, let's get the pith price, because we need to determine the winner, right? So we do that by saying let pith or pyth account info is equal to and ctx.accounts.pith. Okay, cool. So then let's say the feed, right? So we gotta load the price feed now, right? Because if you remember, this right here is updating constantly. So we need to know, as you can see, it's like moving slightly. We need to know what the current price is at the moment. So we said load price underscore feed from underscore account underscore info pith underscore account underscore info. Right, and then you can add a dot map here right after dot map map error, error, and then this bar. Oops. And again, I learned a lot of this from looking at the documentation and testing. So oops, you do this, and then you can say space error exclamation point, and then if there's anything that goes wrong, we say bet error, you got the invalid Pyth account. Remember that error we made earlier? So we're gonna use it here if that error exists. All right, so if it's good, there's no error, we can keep continuing. So we say price data is equal to feed dot get price unchecked. All right, so now we can get the price in price data, and I'm gonna hit enter again. And let's do a require here, and we need the price dot data dot price, right? So yeah, and then a less than equal to again for f64, that float 64, and the max that it can accept as signed integer 64, comma bet error, right? So remember the price too big error that we made, so we're going to do that here. So here's another check. Price is too big. Cool. So first we're checking if it's a valid Pyth account, then we're checking if the price is too big, and then we can, after all that's good, we know that the Pyth price now, Pyth price is valid and it's equal to this variable, which is going to be the price data dot price, and make sure it's as f64. Okay, and then now we can put in the message here. for ourselves. So say pith price is colon, and then if you put this curly bracket here, it's gonna fill. It's just kind of like a placeholder, right? Where if I put pith dot price here, it's gonna take whatever the price is. So let's say the price is like $2. It's gonna put this in the curly bracket, and the message will read that the price is 2 Solana or 2 Sol or $2, whatever it is. Cool. Now we need to adjust prices to compare them with pith's price, right? So we need to compare the guesses essentially that player A and player B wrote and compare it to the current price and see who's the closest, right? So this is another place with a lot of checks, okay? And then we also want to just make a note here, real price is equal to pith price times 10. This is something that it took me a while to figure out, but there's something called a pith exponent, and that's just the conversion that we need to compare. All right, so the real price is this. The real price of the stock is this price times 10. Okay, so keep that in mind. So we can say we can store that multiplier in a variable. I'll call multiplier is equal to 10f64.powi, and then you can say dash price underscore data dot expo, right? Yeah, there's gonna be a lot of troubleshooting after this because this is where your Apple can go wrong most of the time. So you're might be here a while. Cool, that multiplier is equal to that. And then we could say we need to get the player A and player B's adjusted bet prediction. So we can say let adjusted player A is what I'll call it, equal to bet dot prediction underscore A dot price times the multiplier. Okay, and then we could do let adjusted player B is equal to bet dot prediction underscore B dot, and this is the one that's in the option, right? So we have to do the B dot as ref dot unwrap it first, and then we could do a dot price. Yep, and then times it by the multiplier to get it to compare it to the pith price. Multiplier. Nice. Okay, and then we can say the message here, just for sanity's sake, and say the adjusted player A prediction is now this, right? And then what we're gonna put in the curly brackets is this variable player A. Cool. Okay, same thing here. I might just copy and paste it to save some time. Nice. Okay, and then just make sure you change this from player A to B, and this should be player B as well. Okay, awesome. Now we have to compare the price, who's the closest. So we can do this by saying another variable, let abs player A is equal to, parentheses here, pith price, or what the pith price is, minus the adjusted underscore player underscore A, and then dot absolute abs, and then same thing, player B, ABS player B is equal to pith underscore price minus adjusted player B dot abs, and then whoever is closest should win. So how do we check for that? Well, we're gonna need an if statement here. If abs player A is less than abs player B, who should win, guys? All right, think about that for a second. If the difference of the pith price and the adjusted player is less than the difference of this and player B, who should win? All right, well, if the adjusted price is lower, that means there's less of a difference, which means it's the closest, right? So then you can say if this is true, the winner is, drum roll, winner is player A, and then you can say sending this much LAN ports, right? Because everything that's happening here is done through LAN ports, and then later we got to convert that to Sol when we give it to the player, and then comma, the thing we'll put in the curly brackets is the prize. Okay, cool. So now we can do a bet.state is equal to bet state, right? We gotta change the state because it was started, but now after player A wins, we have to say the state is player A won. All right. If you get an error here, it's because you probably spelled it wrong. Okay, and then now we have to update the CTX account. So we can say CTX, CTX, and I'm gonna hit enter here, and then tab so that I can format it like so. That accounts, dot player A, right? So I'm just going to my context, I'm getting the accounts, I'm going to the player A, and I'm gonna get the account info in there. So so to get the account info, I'm gonna say dot to account info, and then let's get the LAN ports. Try borrow mute LAN ports, question mark, if there is LAN ports, plus equals prize. Let's go. Cool. All right, you with me so far, guys? If that's the case, it's gonna add get LAN ports from this equal to and add it to the prize variable, and then we can close it off. So where's the closing one for this? It's right here, because now we need an else if. What's gonna be the else if condition? All right, I'm gonna give you guys 3 seconds. 3, 2, 1. Right, the else if is the opposite, right? So which is abs player B is less than abs player underscore A. All right, and then this is gonna be the same thing. We can copy this message and the bet state actually. All right, except change this to player B. Make sure you change it. And the bet state is not player A1, it's gonna be player B1. Okay, cool. And then from there, same thing, we need to go into the context again. So CTX, and then I'll do this format. Dot accounts, we're in the accounts. Now we can go into player B, but remember player B should be option, but then we can just get the account info because we got it before. To account info of player B, and then let's try to borrow mute, and then get the LAN ports, and then plus equals prize as well. Okay, cool. So we have the situation for A, we have the situation for B, and let's see. Oh yeah, there is an else statement, right? Because the last possibility is what? It's the draw, right? So then we can say, and what should happen in a draw, right? Let's think about this. In a draw, everyone just gets their money back, right? Let's for say whatever reason you had the same exact guess and you have the same distance from the real price, then we can set up a variable called draw amount is equal to the bet.amount, right? And then you could say message here and let them know it's a draw sending both players LAN ports. Oops, you don't need to put this in curly brackets. LAN ports. Okay, and then what is in that curly bracket, you can put the draw amount. So sending both players like 2 SOL. If the price to match is 2 SOL, and in the winner would usually get 4, but in a draw they just get 2. They both get 2. So the draw amount is here, and then semicolon, we say the bet.state. Bet.state is equal to bet state draw. Cool. Yeah, like I said, there's a lot of checks in this bet prediction app. Again, there was it can get even more insane, right? Depending on the complexity, right? So this is a simplified version actually. So let's return both players amount, right? Back. Okay, so let's return it. So we have to do this twice. So CTX dot accounts. Let's do player A, underscore A dot to underscore account info, and then try borrow mute LAN ports if there is available, plus equals draw amount. So we're both sending them the 2. Okay? And then same thing here. Well, we're just gonna do this for player B. And since it's the exact same thing, we just gotta change one thing. Player A to player B. We should be good to go. So after that closing else statement, I'm gonna hit enter. And from here, we can just say, okay. Whew, okay, that was a hefty function. What I'm gonna do is hit build and let's just troubleshoot this because I'm not sure if it's perfect. All right, there could be some spelling errors or some semicolons I forgot. So let's go ahead and do some troubleshooting. All right, let's see what we need to work on. So let's do build and yep, as expected. So let's go over all these errors. There's a lot, right? So the first thing is gonna be mismatch closing delimiter. So that should be an easy fix. Going to line 222. 222, and it might seem like a lot, but maybe some of these are caused because of the first error, right? Because that's how strict Rust is. So let's take a look. And taking a look at this, I can see that usually this has a closing parenthesis, opening parenthesis, and it doesn't close right here. So let's close that off. And let's just run it one more time. Okay, so building here. So expected semicolon found bet. So again, means we forgot semicolon, line 114. In the lib. Yes, in our message. We need to copy that, and I'm pretty sure we did copy paste this, so we need to make sure you copy paste the semicolon as well. So did we do that? Yep, here's a message. And one hack is that you can actually clear the terminal by saying clear. So we can start fresh, right? Easy on the eyes. Hit build. Okay. Expected a comma or a closing curly bracket, but found an exclamation point. Again, in our lib. So 122. Oh, see, notice how this message here, right, isn't the same color as this message here, right? So that means there is something weird with this. Trying to sit here, think about what this is. Something to do with what's before. There is a curly bracket for it. Oh, I see. There is a space here. Hey, okay, there we go. Awesome. All right, I forgot to put underscore B. Let's just clear this again. Hit build. All right, what's next? So, cannot find context in the scope. That's interesting. So let's go to 87. And it can't find a claim bet. So let's just check down below. Did we have claim bet? Yeah, we do. Oh, did I write context wrong? Context without the T. So we need the T in there. Don't forget your little T. So let's go ahead, clear. Let's hit build. All right, so we need 99. Yeah, this is why it's good we're doing this now. But require needs an exclamation point. All right, so let's add that exclamation point. Did we use require anywhere else here? Nope. Let's do a clear. And a build. Price 99. Yeah, there's no such thing as price.data. It should be underscored data. Okay. Hitting build again. Pith price not found in scope. Cool, so that's a lot less errors than before. Pith price is not found in scope. And it's probably one of those things where it's like underscore price again. Okay, 107. Cannot find multiplier, the spelling, right? Yeah, at least the errors are not like code breaking so far. It's just spelling. 99 and needs max. Alright, so I just took a moment to clear a lot of these spelling errors and semicolons. The next thing that's not either of those things is this error right here. Alright, if you look closely, it says could not dereference. That's what this star is. And it's in line 124, so let's take a look. Alright, we should be able to dereference it because it didn't give us any problems in 116, right? But it's giving us problems in 124. So let's take a look. Okay, so this looks like it's fine. We're going into accounts, player B, to account info, same. Try, borrow, lamp ports. Oh, okay, I see. Let's see if we add this semicolon here, because we have to make sure that we're able to do that first. Awesome. Okay, cool. I think that fixed it. Yep, it needs a question mark here. And now we just have the one error, which is 219, and I feel like it's a spelling error, which you guys know that we could fix. So 219 predixiton, right? This switching of the two letters can break your whole code, but if you put it back to normal, it should be good to go. Fingers crossed. Building, come on. Let's go, build successful, guys. So that means no errors, not even any warnings anymore. Notice that it's nice and clean, right? We're using all the imports that we have. And now for one last function, which is the close bet, and then we can move into the front end and put this into an app. All right, everybody. So we're on to the last function. If you made it this far, you guys are crushing it. So really proud of you. If you're here, comment down below. Let's go. So I know that you made it this far, right? We have one function left on the smart contract, and that's going to be the ability to close the bet account, right? Because let's say you claimed the bet already, right? You got the money. You need to close the account, right? When you close the account, the money that you spent to get space there, which is not a lot of SOL in the DevNet, you get that money back, right? So you can do that by saying pub fn close _ bet, and then we can say the arrow like so, result, and then curly bracket, and then from here you can say the CTX. And one rule is if you don't use the CTX in the function, the context, you have to put an underscore, and we're not. All right, so let's quickly make the close bet struct. So I'm gonna come down below to the bottom, and you guys know the deal by now. You guys are pros, right? Spent almost an hour right at this point, so we can say derive accounts, right? Derive accounts, and then from there we can say enter, name your struct, which should be just close bet, info, curly bracket, boom. So this curly bracket represents the information of this struct. So let's get what account do we need? The bet account. So we say account, right? Do we want to initialize? Nope. We want to get the mute, right? Because this could be different bets that we're closing, so we need to make sure it's mutable. The seeds, how do we get the bet, the exact bet that we want? Well, you need to put in the string, the binary string, and then you got to pass in the ID, and they should have different IDs, right? Since we're incrementing it each time we are making a bet. Cool. Convert it into bytes because that's what the seeds need to read. And then we can say bump, then we can say close is equal to play it, right? You haven't seen this one before. Close, just like init, when you write init, initialize it, this struct actually handles the closing of the account for you, so you don't need to write anything. So you can say close, right, is equal to player, meaning the player who created the bet we're assigning is allowed to close. So you can say, and then we can make that functionality by adding this constraint here, which is validate close bet. And then do we have that in utils? We do not. So we do have one more utils function to make. So let me just write this out. It's going to be and, oops, reference this, and then star bet, comma, player dot key, parentheses. And then you can have outside of this at the bet arrow, which we should have, which is cannot close, right? Only the one who created the bet should be able to close, and then we can make that functionality in our utils. So all we have to do is come below here and say pub fn validate close bet, right? And then we can get the bet like so. Okay, and then you can do that by saying bet here, the type reference the bet, and we do need the user key, right? So we can say user key takes in user key, and it has to be pub key. That's the type, and this will return a boolean, right? And then we need to do a match statement here. So we say match bet.state, and then the bet state colon created equals arrow bet.prediction, right? Bot prediction, right? Yeah. Underscore a dot player is equal to user key, right? Because the one who created the bet is always going to be user A or player A. So we can set that equal to the user key, right? We can also do bet state colon started, right? The is player, is player, pass in the bet, right? So you're probably wondering what is player is. This is the actual function that checks if the user is a player. So we can pause that for a second. We can say fn here because it doesn't have to be public. So we say fn is player because this is the only place we're going to call this function. It's going to be bet, reference the bet again, comma, get the user key once again, pub key, turns another boolean, forgot to put bool here, and put bool here. Okay, so is player, we can check if there is a player by doing bet.prediction underscore a.player is equal to the user key, right? Just like before. And then you can also do or, right? And I press tab here to format it, or parentheses the bet.prediction b.is underscore sum, right? Checking the option, and bet.prediction underscore b.as ref dot unwrap, right? Because remember, b is an option. We need to unwrap it. Then we can go into the player and then check if that is a player. Okay. Cool. So now this should make a little bit more sense. We check if his player is in here, pass in the user key of player A. Yeah, and then we can do an and get Unix time stamp bet.expiry underscore ts plus the maximum claimable period. Okay, cool. And now we can just check the other states, right? Because the bet state is player A1. Then the bet prediction underscore a dot player is equal to the user key, comma. Then the same thing for B, player B1. Right, so these are basically all the times that you can close the bet, right? If the bet state is A, then player A can close it, started. Player A, you have to check if the player is a player, and then the maximum claimable period, it's greater than that with the timestamp, the current timestamp. We can close the bet, and then if player A or player B1, you can still close the bet. So bet.prediction b.as ref, because this is an option, like I said before. So you gotta unwrap it. Dot player is equal to the user key. Yep. Bet state draw, and then we can use is player here again. Okay, and pass in the bet and the user underscore key. Cool. And we just need a comma here. And that should be it for the utils. So let's go back to our lib, Right, so then we have to validate the closed bet, pass in the player key as the user key, and then it'll run through the logic depending on the state, thanks to our match statement. And if it returns a Boolean that is false, error, cannot close, right? So that's how our error handling works right now. So we can make this the bet account info, and then bet, comma, and then let's get the player. So we can say mute, and the player is basically the signer. So player : signer. We don't need to get an account for that one. And then you can do pub system underscore program info system. Okay, cool. And that's it, guys. Close bet is pretty simple because all you have to do, since the struct is handling the close, all you need to do in here is just write okay, and that's the logic of the close bet, guys. Isn't that insane? Oh, okay, I'm struggling with this. Let's try one more time. And not that one, this one. Hey, okay, that's the close bet. That should be all the functions. Let's just test for any spelling mistakes or errors, and then we can move on to adding this to the front end. And this time, let's just actually look at the close bet. I'm just gonna do a sweep, so maybe we can minimize the error just by just proofreading it. So back to here, close bet. Let's put in the context. I just noticed that context is gonna be close bet. Okay, and a lot of that logic was in here. Validate, close bet, player key. Yeah, what about in utils? Did I spell prediction right? I see one, prediction, right? That's one way to spell it. Create should be created. And I think the rest might be some spelling errors I missed. Did I spell prediction right? Prediction. Okay, looks like I spelled it right. Let's hit build. Ah, yes, of course. So lib 248. Oh yeah, commas, can't forget that. Oops, let me hit clear. Oh, let's go. That is like a world record. There's one error, and it's just the context spelling again, 149. Keep forgetting that T. Don't forget your T's, guys. So context, right? And then we hit build. Build successful. Let's go. All right. Now, next step, let's take this code and move it to our front end. And to do that, we first need to hit upgrade. All right, and to upgrade, I went ahead and cleared my terminal, right? And all I have to do is make sure you have some Solana. Let's hit upgrade. And it's gonna deploy. And if any issues come up, it should let us know, but that's why we do build first before we deploy. So let's go ahead and wait, and I'll check back in when it's done. Hey, deployment successful. So we have our upgraded smart contract. The next thing that you should do is look at this IDL and make sure you hit export right here. And if you're on Chrome or any other browser, it should show your IDL here. Don't mind the number 9. That's just how many IDLs I have in my downloads, right? What you could do is go ahead and click it, and I'll open it in VS Code. Okay. Oops. What you want to do next is Alt Control B, and you want to get this IDL inside of your utils, right? And just rename it to just say IDL if it doesn't already. Boom. Okay. If I hit save here, it should format it. Oh. Where is it? There you go. Cool. Couldn't see it for a second, but if you look, this essentially is all the information about our Solana program, right? Create master, create bet. We need this because we're going to be pulling that IDL in here. So go to your constants and let's fill out any constant variables that we're going to reuse over and over. So what I'll do is at the top here, we do need to import one thing, and let's import public key from Solana Web3. public key Solana web3.js, and this stays the same. But we need to do is export const. We also need to get the program ID. So what is the program ID, guys? Well, it's going to be a variable that holds, and we're going to use this import, make a new instance of a public key based on this string. Okay, what string do we use? Well, simply just go to your beta.sol.pg, click copy this whole thing. This is the address of where your program lives on the blockchain, and we can just hit paste here. Oops, there's already quotes in there, so we don't need these extra quotes. Boom, right? So this is our program. Yours is gonna look different than mine, but it should be similar. Okay, next is we should also keep the export const minimum remaining time until expiry, right? This is the one that we can change to make it more fair. Boom, minimum remaining time until expiry. Cool. And that should be all of our constants. Awesome. So remember when I was explaining how each of the functions work? Some of the things we can do is put that in our front end and pass it into our Solana smart contract, such as this minimum remaining time until expiry. We can use this, right? Another thing we should do is head over to our program.js. So it should be in here. And inside program.js, we can have a lot of our helper functions for our Solana program. So let me show you what I mean by that by doing something like this. And let's hit import and let's get a couple of things. I want anchor provider, and then we want big number, which is BN, program, and this is going to come from project serum anchor. Okay, another thing we need is that public key again, because we're going to convert a couple of strings into public keys. Okay, and let's get some of our constants in here. And then what we need from the constants is import the minimum remaining time until expiry and the program ID. Cool. What's up next? We need to get well, actually we can get that later, but we need to get the program, right? So we can create a function, right? Create a function that gets the Solana program we created, right? So how do we do that? We need to say export const, const get program, that's what we'll call it, is equal to a function. All right, so what does our function do? Connection takes in, and it takes in a wallet, right? And then we can say const IDL, right? Where have we seen IDL before? We've seen it not there, right here, the IDL we just brought in. So make sure you have your IDL. So IDL is equal to require /IDL.json, right? So we can get the ID, bring it in here. And then we have to set up what's called a provider. So the provider is going to be given through anchor. So say new anchor provider, and it's an object here. Oh, sorry, not object, it's a parentheses here. And then you can say connection and wallet, right? So the connection and wallet that we passed in is going to come into here. And then you say anchor provider dot default options parentheses. There you go. So that's the provider variable setup. Next thing we need is the program. So let's set the variable const program is equal to new program, right? One of our imports, and set the IDL, the program ID, and the provider. And that should give us the program information and create a new instance of it. And then all you have to do is just return it. And there you go. That's our program. So get program, takes in connection wallet, set up the IDL, the provider, and use that to make the new instance of our program. All right, cool. Now, a couple other things while we're here. We also should remember how we have to fetch bets, right? Usually when you fetch a bet, you can just do a fetch all, right? Or fetch all of master, right? But you can get a specific account by putting in the public key. So let's look what happens when I take the master and just put that to fetch. Boom, that's this one singular account object, right? So we need to do the same thing and write a function that gets the program account, right? So we can do that by saying const get, other way around. export const get program account, yeah. And then PK stands for public key. So this is going to be an asynchronous function because we're going to make a promise. All right, this is going to take in the seeds, right? Usually when you get an account, you need the seeds. Okay, so then we're going to return, and we're going to say await public key, right? And we have public key, right? Yep. And it has a built-in method dot find program address, right? This is how you can find a program using this. You pass in the seeds and the program underscore ID, and then you have to do bracket parenthesis 0. Okay, cool. Async await, boom. Okay, and then this shouldn't be here, so let's do a find program address. There you go. And this doesn't need to be exported because we're going to be reusing that a lot when we get the other account, so that's fine. Okay, and then let's start using that function. So we can say export const get master account pk, right? Because we want to be able to fetch the master account that we create, and to do that we're going to say async. We don't need to pass anything in. All we need to do is just say return await get program account pk, and then pass in the seeds, right? So if you think back to our app in the Sol playground, right? If you go here, how did we create the master? We had to put in the seeds. And then how do we even fetch the specific master? We have to pass in the master seed. And if you know, this is the string. So we have to format that here and press basically an array and do this buffer dot from, and then you can say master. Right, this is the same thing as us writing that binary string master in Sol PG. Right, works the same way. Cool. So after we did that, we should get the bets. Right. So how do we get the bets? You can say export const get bet account pk. This is asynchronous. And does it need to be passed in anything? It does. Right. It needs to get past the ID. So get the ID in there. And we're going to do something with it. We're going to say return await get program account pk. Okay, and we say this, and what we want to put is that buffer, because we do put a string in here. And what was that string? It was bet. Right, so bet comma, and then we need to pass in the ID, and we can turn that into bytes, right? So to do that in the front end in JavaScript, you say new bn, that import we used, ID dot to array like buffer comma, and then remember we did the le, so comma and then 8, and that's how you do it. Okay, there you go. Okay, so the next thing that we have to do is let's go ahead and set up our state. So if you go open up this folder, go to global, you're gonna see that it's empty. Well, we gotta set this up and then wrap our entire app with our state, and you'll see what we'll use it for in just a second. All right, so essentially our global.js is gonna be our context. So in order to create the context, we need to say import, and then say create context, and you get that from React. All right, but there is a couple more things that we need to import, which is going to be a use callback hook, as well as the use effect, and I believe use state. Yep, use state. Awesome. All right, and then from there, we can get this import. It's called lamp ports per Sol, right? Because we're going to do some conversions from Sol to lamp ports and vice versa, because that's what our contract likes to read it in. So let's import another thing, which is going to be use anchor wallet and use connection. And this is going to come from Solana wallet adapter React, which we've used before. All right, cool. Now we remember those functions that we created, bring them all in here. So we could say get program, get master account pk, and get bet account pk as well. All right, and another thing I like to do here is use toast. So if you saw the demo, this is where we got those notifications where you can get React hot toast. Awesome. All right, and then to create a context, to get started, you just say export const, and you can give the name of your context here. I called it global, so let's say global context is equal to the create context hook. So we say create context, parentheses, and then inside takes in an object with all of the stuff we want to pass. All right, so I could tell you all the variables that we want to pass on throughout our app, and it's going to be is connected is one, and that could be set to null. We could have the wallet, null. All of these are going to be set to null, and they will be defined later on. Right, has user and account, null. All bets, right? We need to have a variable that holds all the bet accounts, and that's null. We need something that fetches the bets. We also need create user, create post, null, and then update the post, null, delete post, null. Actually, no, we don't need these. Okay, I'm gonna go back. Yeah, I think those are fine. We can delete those. Fetch bets. Do we need anything else? No, I think that's it. So we have those, and then we can get the global state. So export const global state, and set that equal to the children. Okay, and then from there we just do an arrow function here, and then say const program, comma, set program, right? This is a state variable that's going to hold the program of our app. And while we're here, let's go ahead and set up the other states, like is connected, set is connected. We can also say const master account, right? Because we should save the master account, and there should only be one per program. So set master account is equal to use state, and we can say const all bets and set all bets, right? So this is the state variable that holds all the bets that we fetch. Set that equal to use state as well. And there's also an optional one, which is going to be user bets. So we want to save all the bets that are relevant to the user, and then say set user bets like so equals use state. Okay, and last one is just essentially just, yeah, we could have one more, but I think we'll save that for later. It's gonna make more sense. And then from there, we can just set up the connection. So if we see our import, we have use connection here. Let's set that up by destructuring it and saying connection, and saying equals use connection. And then there's also anchor wallet, so we can set that in a variable and say const wallet is equal to use anchor wallet, because this will return for us a wallet and store it in this variable. All right, cool. So now that we have a lot of the things set up, let's get to writing out the logic of the global.js. Okay, and then don't forget we need to return here, and then put parentheses, and then what you want to return is the provider. So you say global context provider, or sorry, context.provider. Yep, and press enter. And the key here is that the global context.provider is going to have a attribute called value. Set this equal to an object, and anything you put in this value is going to be what is going to be in our context, right? And in between the provider itself, you have to pass in the children. Okay, so make sure you have children here. Make sure you have children here, and in the value, let's say we make a variable, it's going to be pulled out by writing it inside of here. Awesome. One thing we do have to do is go to hooks, and if you don't have this, make a file called useGlobalState.js, and then you can uncomment this use context. So now it exists, right? Because it's just using the context now. And what context are we using? The global context, right? But one thing though is that our app doesn't have it just yet, because we have to import it over here. So at this point, you are in your app.js, and what we have to do is around here, we have to say import global state, right? Import global state from state/global, right? The point of this is so that we can wrap our app with the global state. So we can go, it should go like right here. And say global state, and then put that in between our app. All right, and there's only one way to test if this works, is let's say is connected is a variable here. Let's make a variable, let's call it let connected. All right, let connected is equal to true, right? And we can pass connected like so. Okay, now it's not grayed out. And then we can go to, let's go to our index page, and let's import the global here. Yep, here's the hook, use global state. And we can say something around here. Const use global state, and we want connected, is connected. And let's see if this works. Console.log, oops, connected, and hello world. All right, I'm putting this comment here so I know which console log this is. So let's go back to Playground. It's been a while since I opened this one. Are we running our app? Yes, we are. Let's see, it might be blank. Oh, it's true. Let's go. Right, so that means our global state is working, right? So how does the context work? So let's picture our app. So I'm back in the whiteboard. This is our app, right? And it has a bunch of components like index, and the index has header and portfolio, right? So this is the header, and this is the charts, right? And this is the index. All right, so usually all components have a hierarchy, a parent-child relationship, and let's say I wanted to have a connected variable. In order to get that to the header, I would first have to pass it to the index and then pass it down to header as a prop, right? If you have a long list of components, that's going to be called prop drilling, and it may cause some issues down the line. Another alternative to, instead of passing it like so, oops, lost the rectangles here, boom, boom. Another alternative, instead of making it an app, is to create what's called a store or a context and put it in here, because with this context, I can just pull it from anywhere. Right? I don't have to pass it down from parent to child, right? So that's why we did that. So that's my really, really fast crash course explanation on that context. But as you can see, we have connected available to us. So we can put in a lot of our functionality in here. So we can erase that. And now global.js is all set up. So the first thing that I want to do is let's use useEffect and let's set the program, right? Set program. Okay, so useEffect is going to run several times depending on how you structure it. So if I do something like comma array, this is called a dependency module, and it will only run once, right? We want this to run more than once. But the first thing we should do is if a connection, right? If there's a connection, then we can set the program to get program, right? And we can do that because we passed in get program from our utils. So all the setup is coming into play, guys. Don't worry, it was all part of the plan. So we say connection, then we say wallet, and then you do question mark object here. Okay, so if there's no wallet, just use an empty object. That's what that is saying. And then the else, right? If there is no connection, then set the program to null, right? And the cool thing about our program, it does have a master already, so we don't need to create that. One thing to note is, again, this makes it run once, or it runs once when it first loads, or whenever the connection changes, right? So if the connection ever changes, it's going to try to set the program again. If the wallet ever changes, when I switch wallets, it's going to set the program again with that new wallet. So that is important, okay? One thing we should have is another check, which is going to just check for the wallet connection, right? So we can do this with another useEffect. There's going to be a lot of useEffects, guys, so get used to it. So useEffect set is connected, right? I think I have that. Yep. So you can say this if there is a wallet, essentially dot public key, like so. it's a double negative in that sense. And we can have a dependency module that only happens when the wallet changes. Oh, not that one, this one. Nice. Cool. And if you don't know what this question mark means, is if it exists, right? So if I don't put this question mark, you might get an error that says undefined dot public key, right? Because it doesn't know what this is, right? This is only going to run if wallet exists. It'll only get the dot part if there is a wallet, which happens sometimes when you first load the page. All right, now for the first tangible thing that we can see is a checking if the master account is there, right? So we can say const fetch master account, right? And it's gonna use callback. So we're gonna say use callback and say async arrow, and all I have to do is if there's no program, then we can just return, right? This won't even run. Okay, there's still more because we can do a try catch here, not page transition, try and then catch. I usually set up my catch first, it doesn't really matter. And then for the console log, couldn't fetch master account, and then we could just put the e.message here, e.message. Okay, and then for the try, we're gonna say we have to get the public key first to get the master account, right? So we can say const master account pk is equal to, and usually you have to write a lot of code just to get the master account pk, but luckily for us, we made a reusable way to do that. It's this function right here, boop. So bring that function down here and just say get master account pk. So if we did it right, this should work, and it should get us the variable, and then we could say const the master account itself, right? We can say await program, because program is going to have all the accounts, .account .master .fetch the master with the specific master account pk, and then set it to this variable. And then once that's done, we can set master account to that variable, right? So it all should make sense. If this fails, this master account should just be null, so we know it failed. And what we could do is just pass that here, master account. Right, I think that's what I called it, yep. So I pass it in value, which means it's in our context. So I can go into here, instead of connected, let's do master account, and let's say master account. So it should show the master account that's created if it exists. So I'm gonna go back to here, to refresh, to inspect, undefined. So it doesn't seem to have the master account. And if I double check, yeah, still undefined. If I double check here, it should have one, right? It should say, it should have an object like this that we fetch. So that means there's somewhere where it went wrong. Let's go double check. Let's see if it's even getting the program. So let's pass in program. Is there a program here? Program. Oh, well, program wouldn't be here. It should be here. Program. Yep. Set program. Oh, I mean, it would be helpful to call the function. So let's call this function. It's still grayed out. So we should call this in a use effect. So what I'm going to do is down below here, we could say check for master account. So then we could say use effect and just do a check. If no master account and program, oops, and program, then fetch master account. Dependency module should just be a master account changes, try this again, or if the program changes, then try this again. All right, so if there's no master account and there's a program, we need to get the master account. Okay, so let's see if that works now. Hey, all right, we got it. Look at this, last bet ID, BN, right? It's BN, because that's the format it's in. So it should be 0. If you want to read it, you have to go into index, right? The trick with big numbers is that JavaScript can't really read BNs, so you can just do a dot the property, which should be last bet ID dot to string, and then we should be able to see it, right? 0. So anytime you want the actual number itself, do a dot to string. So that's the pattern, that's the logic we're using, that's the master account. Amazing. Okay, so master account is done. So we successfully created a way to fetch all the master accounts and then check for them. We should do the same thing for all the bets. So let's make a function called fetch bets is equal to use callback and then say async arrow. Boom. Okay. And then same check. We always do this. If there's no program, then you should just return. Same thing is const all bets results. Right, result. Right, and we can get all the bets if we do await program dot account dot bet dot all. This is how you get all the bet accounts in your program. If there's none, you'll get none. But then from there, you can say const all bets is equal to all bets result dot map. Right, because the reason we want to map is to get every single post. Right. And then, well, every single bet, not post, bet. And then from here we can say bet.account, and that should give us just the bet object itself, because otherwise you get the whole thing. We don't want the whole thing, so we can just do this, and then take that and set all bets to all bets. Okay, and then if I were to pass this down here, it should give us nothing. We can also just filter user bets, but I don't think we need to filter user bets just yet. You can just make it to show all the bets in general. So yeah, I'm just gonna comment, if you want, you can use .filter to get just the user's bets, right? But the way our app works, we should see all the available bets, even if we didn't create it ourselves. Okay, and then there should be a comma here, dependency module program. Okay, and then now, yeah, get and update all bets. So it's kind of like what we did with the master account. We can set up one more use effect, like so. And in this use effect, we want to fetch all bets if all bets does not exist. All right, so if it doesn't exist already, let's get them. So if all bets. Okay, then we can say fetch bets. Okay, comma, and say if all bets change, then run it again. If fetch bets changes, then run it again. So now this function is being called, and just to test it out, it should be nothing because we don't have any bets. So let's just pass this down. All bets. Okay, and then an index. Do all bets, and then console.log all bets. Should be empty array. Yep, empty array, because we don't have any. And we could double check that with Playground, and you can see empty array. So it's still pretty accurate. Awesome. Okay, now we can go back to global.js and work on the next thing. All right, keeping it moving, we are going to our first function, which is going to be creating bet. And we can actually test if creating bet works on our contract as well, if this goes well. So let's do create a bet. I'm gonna go down here, const create bet. And this is gonna be a use callback just like the other ones. And it's gonna take in an async anonymous function, right? Make sure it's an arrow function. And inside of this async function, what do we need to create a bet, guys? Right? Think about it. We need the amount, we need the price prediction, we need how long is your bet going for, and we need the pyth price key, right? So we need all those things, and then inside this async function, we have to do the if there is no master account, right? We can't do this. Otherwise, the master account can't increment each bet. All right, so make that check in there. It's our edge case. And then we have the try catch, which I'll set up just now. E, and boom. Okay, toast dot error. Yeah, so it's our first toast dot error that we will see a visual cue. I'll say failed to create bet, right? And then we can have a console log of the error dot message. Okay, cool, because we'll get the toast notification it failed, and then a console log of what exactly happened. So that sounds good to me. And in the try catch, we can just say const bet ID is equal to the master account, right, which we'll have access to, dot last bet ID, and then to increment it, we could just do the add one. Next is we have to make a variable called response or res as equal to await. We have to get the bet account PDA or PK and pass in the bet ID, right? And again, if it doesn't exist, if there's no bet account that exists yet, it will create one. So we can say console.log, and then we can just visually see it. In this case, bet PK, and inside we say res. Okay. So then after that, we can make a transaction hash. It's gonna show us when it finishes. Program.methods, and we can look at this through SoulScan or Soul Explorer. From here, every program has a .methods, and the methods that we can call on is our Solana instructions that we created together. So we can do that by saying wait, we can't press tab here. Let's hit back dot create bet. So I'm calling the create bet function from Solana Playground. Amount, price, and duration. Right, we're gonna pass that in as well. And then pith price key dot accounts. We gotta pass in accounts. This is our context, and the accounts that we need to pass in is the bet account, which is gonna be await get bet account PK bet ID. Okay, and what else do we need? We need the master, right? Because if it doesn't exist, we can't run this anyways. Await get master. This is why I love that we made those helper functions. It makes it nice and easy. Don't need to pass anything into that one though. And then the player, right? The player is easy to get because we have access to that when we say wallet, and then we can just get the public key, because that's what it needs. You don't need to turn it to a string. And then last but not least, you should write this .rpc. Okay, and then we can say await connection.confirm transaction, and then pass in the hash, right? So we need to confirm that this transaction went through, and usually what you could do is console log created bet, and then show me the hash. That's why we made the variable. And then I also like to put a toast.success here and say created bet. Cool. So there is our create bet function. Okay, and then there is one more thing though. There's catch here, then there is this here. We can put a comma, and then we have to put in the dependency module is if the master account is different, then that is going to determine the bet ID. So that should be here. Okay, so let's put fetch bets, and let's try it out. So I'm going to go to the index and let's figure out where to fetch the bets. Right, so how do we fetch a bet? It should be through the submit button, right? So I'm gonna go to find out where that submit button is. It might be in the index. It's been a while. Yeah, it is. Right, and you can see that I actually commented out what we need to do. So erase static bet and then comment out this right here. So the first thing that you should understand is this e.prevent default. This is needed here. Otherwise, if you hit submit on a form, it's gonna refresh your page and we lose all our states that we set up. So make sure you have this so that it doesn't refresh. Next, we need to get create bet, right? Because right now it doesn't exist. And we should go back to our globals. I put fetch bets, but it really is create bets. Yep, create bets, create bet. Cool, that exists. Save, and back to our index. And instead of all bets, well, we can keep all bets there. We say create bet. And then we console log create bet, just to see if it exists. And it should give us a function that's not running. We did this right. Yep, function amount. Nice. So it does exist. It's the right name. And make sure it's in the on click of the submit button, right? So what's happening here? It's gonna take the amount of sol that we type in, right, in the input field, that's what this sol is, and convert it into lamp ports, right? Because when we take something into Solana, it doesn't work with sol, it works with lamp ports, and 1 billion lamp ports are in 1 sol. So next is the guess, right? What is the prediction price of the stock? And then lastly, the time, which I'm gonna put to like 150 seconds, for example. And then lastly, the price key. So how are we getting the price key, right? You remember, if you look at here, you have to come down below, get the price key that you want, right? So that's what you have to do normally, but I've hard coded some of that for you here. So if you look in the data, stock data, right? This is coming from data.js. Should be somewhere around here. Yep. You can see that I have a price key of each of these stocks so that you don't have to. And then the graph that you're seeing, that's not real, it's still static, right? If you want the real stock prices, you could just use an API, not really through the Pith network. The main functionality that we're teaching here is how to use it in your Solana program. But again, if you want to see that, comment down below. So back to whatever I was doing, we want to set up the create bets. So let's just double check one more time and let's just try it. Okay, so creating bet, awesome. And let's see what happens. So I'm going back to our app. Let's use the AMC stock, right? You can see Bitcoin, you can see Amazon. Let's go to AMC and then we can X this out. Let's see, so my prediction, I will predict that the price will go lower to 3.8, right? And I'm gonna bet 2 sol, and let's make the bet 150 seconds, which should be around 2 minutes. Oh yeah, I need to log in. Oh, okay, so my wallet is there. This might fail then. Failed to create bet. Let's see, is there what's the reason? A seed constraint was violated. Okay, that's something we can work with. So one theory I have is when we called the function, we might have passed in something that wasn't correct. So we can go back to our global, go to create bet, and let's just take a look at all of these accounts. So I want to console log them before we create the bet itself. So let's do console.log get this bet ID. Yeah, so let's do this. So let's say let bet is equal to this. Let master is equal to this. Oops. And let player is equal to this. Okay, so what I'm doing is I'm just checking to see if these are the right accounts that we need to pass in. Otherwise, the error might be when we're calling the account PKs. So let's do this, and then we can say a console log and say the bet is the bet. Then we can say player, oh, I'm sorry, master. We should do .toString too, by the way, so it can be more readable. .toString. The master. And then the player. .toString. Player. All right. And this is only going to run when we call create bet, so let's try that. So hit this one more time. Okay, prediction 3.8 Sol. It's gonna be 2 seconds, 150. It's mint. Okay, so those are our 3 console logs. Yeah, so the seed constraints are still violated. All right, so let's see. This is the bet account, and let's see if that is accurate. So create bet. Create bet master player. Is that the master account? Yep, 458. 458. The player is a T. So a seeds constraint was violated. Program log 67. So it didn't like when we did the bet. So let's take a look at our utils function. That's my next guess. All right, this is live debugging right here when you're making your app. Program, sorry. And get the bet. So there's something wrong here. Oh, this is a 9. Why is this a 9? It should be an 8. Okay, let me just double check. Yep, the 8. Yeah, so that's the seed constraint, right? So this is where we pass in the seeds to get the bet account PK. I put a 9 here. That's definitely wrong. So let's see if that fixes it. It might not. It might not do anything, but there definitely shouldn't be a 9 there. Okay, so again, the prediction is let's just say 2 or 3.8. Pass into Sol. 150 seconds is the duration. Submit. Different account. Let's go! -2 Sol. This works, guys. Oh, I can't get too excited, but usually when you see that number, that's a good sign. Hey, create a bet. Awesome. So we have a bet here, right? And we have to notice something. We have to see if the available bets show up, right? So what we could do is go to our index, and I think, not that index, I think we already have all bets. All right, we have all bets here, so let's console log it and see if that array is still empty. If it is, then we're not, we didn't make the bet. It doesn't exist. Array 1. Oh, let's go. Array 1, so our bet is there, right? So what do you want to do that? What do you want to do after you have all the bets? We need to get that component that shows all the bet information, which we have made. So let's take a look at our app once again and scroll all the way to the bottom. See this available bets right here? This is what we need to go to. So available bets is all of those components. So let's click on that. Boom. Right? As you can see, we have a static all bets here. We don't want this static all bets. We want the real thing. So we need to import global context again. So I'll say, oh, it's already here. It's already imported. Nice. In line 17. So I'll just say const all bets is equal to use global state. And now it should map through the actual bets. So let's see if it works. And it's the right bet. We did AMC. There's 2 Sol, and we should be able to enter the bet, but we can't just yet because we need to set up that functionality. Let's go. So we have bets. All right, so let's work on another simple one. As you can see here, there's already a X right here where you can close the bet. So let's do that. It says static closing bet function. Let's get the real deal in here. So if I ask you guys, where are we going to write the function to close the bet for our front end? That's right. If you said global.js, you are correct. So go down below here, 116 for me, and say const close bet, right? It's gonna use callback, not anchor wallet, callback, and it's gonna take in a asynchronous anonymous function. Right, so when you close a bet, you do need to pass in what the bet is, right? The specific bet you want to close. And if you say if master account, then return, right? Shouldn't be able to close the bet if there's no master. From here, we do a try catch. You know the deal, guys. Say E, and we can console log. All right, first do a toast.error, right? And say failed to close bet, All right, and then the console log to let me know what exactly happened. Couldn't close bet, and then comma, here is why, dot error dot message. Nice, and then what did we want to try? We have to do the same thing as we did last time. Let's set up a transaction hash variable that we will confirm later. So we say await.program.methods, right? And then we can say dot here, or press enter to format it, dot close bet, right? Because that's the name of our instruction in our program. And then you can do dot accounts and pass in the accounts that you need for the context, which is just two things. It's going to be bet, and then it's going to be await get bet count pk, which we fixed now, thank God, bet.id. Don't forget a comma here, and get the player, which should be very easy, wallet.public key. Awesome, and then .rpc. Alright, cool, and then you can console log, or sorry, you don't even have to console log, you can just say toast.success, right? Because if you made it this far, it's successful, and so you could say closed bet. Now to see if this functionality works, we have to pass in close bet here, and then think about where do you want to call close bet? Where do you want to run that function? So if you look at our app, it should run when I click that X button. And do you know which component that does it live in? I'd say in this one, available bets. So if let's scroll down for the close, yep, you can see static close bet, which means we don't want to use this anymore. So let's erase that, and let's do close bet. I believe that's what it's called. Yep, close bet. And it does need one thing. It does need to pass in the bet right here. And as you can see, if I highlight it, it does know which bet we're talking about because of this map right here. Okay, so when we map and create a component of that bet information, it has the bet stored there. So we could close it. It knows which bet it is. All right, that's what I did in the front end for you guys. So now we can just do a refresh for just in case, and let's see if we can close it, and we should get refunded our 2 SOL. Hey, look at that, plus 2 SOL. Let's hit approve, close the bet, let's go. All right, so that's done. We are able to close any bet we create now. Now we just have to enter the bet and then claim the rewards. Okay, so I think we're ready to set up for entering the bet. So you know what to do. Let's go back to our app, and let's go to global.js, and let's just say the const enter bet. Now to enter the bet, it's the same as all the other functions. This is just us calling enter bet in the front end to call the function in Solana, right? So we're going to use callback here, and it's going to be async anonymous. And think about it. What 2 arguments do we need when we enter a bet? We need the price prediction of player B, and which bet are you predicting on. So price bet. Okay. Then you can just console.log. Well, you don't need to console log actually. Then you can say if there's no master account. Once again, we should just return. Return. And then from there, our favorite try catch. E, and then console.log if it fails, couldn't enter bet, and then tell me why with the e.message. Okay, and then there's the toast.error, so it's the visual cue that hey, this didn't work. So let's say failed to enter bet, exclamation point. All right, so what are we gonna try? Well, you know what to do. Transaction hash is await program .methods, and then we can hit enter just for formatting purposes and say enter bet, and we need to enter the price. We also need to say .accounts, right, and then put an object, and the accounts that we need is the bet itself, which we can say await get bet account to make, because we made our lives easier, and since we passed in bet here, just pass that in to get the ID, right, and it does all the fetching for us, gets the account that we need. Then it's the player up next, and then you can say wallet.public key. There's an error here because of the comma. As you can see, I'm more comfortable with the front end than Solana, so we can just say .rpc here. Cool, and then toast.success if it works. This is my visual cue for myself, and to say entered bet. And again, I didn't do this for the closed bet, but if you want, you can confirm the transaction if you console log the TX hash. Again, optional. You could do something like this, connection.confirm transaction, right, if you just want to make sure. Or you could just console log the transaction hash that comes with this. Cool. All right, so that's entering the bet. Let's put this here. And again, if you think back, it's been a while, but if you think back to our demo, the enter bet function should be somewhere here with all the other information next to our close bet. So let's go to available bets and let's try to find it. So current amount, we might have to create it now. And here is where we want to set up that enter button or claim button, right? So we need to have a button that changes depending on the state of the bet, right? So how do we know what the state of the bet is? Well, we have this console log here, and you'll see what it's used for. So let's just temporarily make a new one. I'm just gonna say 1, 1, 100, right? And submit. And bam, created bet. Nope. Accidentally refreshed. There you go, AMC. Right, we should see an enter or claim button depending on the state here. But if we look in our console, what is our state? Our state is created, right? So if it's created, we should be able to enter the bet, right? So this is how we get the state. Object.keys, give me the state 0 to uppercase, right? Cool. So what can we do with that information? Well, we can just get that right away. So we say object.keys bet.state in bracket 0 and then .to uppercase. I'm making it uppercase, so when I do a check, all the letters is going to be the exact same, or else I'd have to know how to write it exactly. So you'll see what I mean in just a second. So make that uppercase. Object keys bets case to uppercase is equal to started, right? So, and this has to be capital because of the to uppercase, right? Yeah, so this should be started. Started is when player B enters the bet. So this is what I want to do first. First get the started one, and then press question mark here because this is a ternary operator. Essentially, if the set of the bait is started, then what I want to happen is we have a div here. All right, and don't worry about the error, it'll go away in a second. We have a div here, right? What is in this div? Well, in this div is going to be the class name, styles.button. See, we're still doing some HTML and CSS here. Styles.button, and it's going to have an on click, right? Set this equal on click of claim bet. So we don't have the claim bet function yet, so we'll say static claim bet for now, like so. And inside that very div is where we can write claim, right? So if I save this, well, we're still getting error because we're not done. Hit claim, and then you're gonna say or, right, or else. This is the else, the colon here after you use the question mark. So if this is started, load the claim div. If it's not started, then we want enter here. We want object.keys again. Essentially this whole first part. So it's just, we can copy that. All right, so this is a nested ternary statement right here. And this, instead of started, we want to check for player A1. So we have to do all the states here to make it one button, right? You could just have multiple buttons like enter, claim, close, right? But I want it fancy. I want it so that it changes depending on the state. So player A1. So it kind of goes down the nest. So first, is the bet started? No. Then load player A1. Is it player A1? No. Then that must mean player B1, right? So first we'll do the player A1. So you can copy this div, right? And say player A1, right? So player A1, and this isn't on click. And this also isn't a button. This is the available bets title, which I set up before for you guys. And we're not done yet. I have another one, right? Another nest, right? So this one is going to be for the second option, B. All right, so player B1. Okay, and then if that's the case, then it's going to be similar to this one. Oh, sorry, this one. And then we can put V. Tab, save, boom. And then say player B1. Okay, and then if none of that happens, then what we could do is colon. That's when you just see the enter button, right? So the enter button, you don't need another object stack keys here because it's the only other state that's possible. So you could just copy the styles button one. Okay, and instead of this, you just say enter. And we do need to fix this a little bit because it's not claim bet, it's actually enter bet. Enter bet. Well, actually, no, you don't even enter bet here, guys. I was wrong. When you enter bet, you get a little modal that comes up. And to make the modal come up, we have to change this on click to a enter that set selected bet. This is a front end function that I have that's going to open up our custom modal. And then it will say set show modal to true. And we also want to do an on click, and we don't want this to run, so we'll do something like this. There we go. So that's how you can make two functions happen one after the other, is make it anonymous first and then make the two functions run. Okay, let's see what happens. Oh, cannot convert undefined or no. Oh, okay. Oh, okay. So it's not my fault. It's I just spelled state wrong. I put satatate. Okay. That should definitely exist now. Hey, we can now enter the bet, right? So this doesn't actually enter the bet. This does, right? And this is where we can enter our prize prediction. If I hit submit, that's where the static one comes in. Yeah, closing bet. Okay. Cool. So let's go to that, which is the custom modal, which I haven't opened yet. And in here, we have static enter bet. It says closing bet, but we don't need that anymore. We can just get the import, which I should have, use global state. And then how do we get it, guys? You just say const enter bet is equal to use global state like so. And I just gotta make sure I'm passing it here. Yep. So now I should have access to it here. And we have to go to enter. Yeah, instead of static enter bet, we need enter bet. And it's gonna take in the player 2's guessed and the bet that we selected. All right, now moment of truth. I will close this one because it's probably expired in the time span of me explaining and coding that. So let's get our soul back. And let's test it. Okay, cool. So now that I closed that bet, let's test the enter bet functionality and see if it works. So let's get a player B. So what I'll do is I made another window and we can go to localhost again, but this is a different account. So as you can see, instead of AT, my wall address here says 3W. So he should be able to see all our bets as well and enter as player B. So let's see how much Solana he has. He has 5 SOL. All right, so 5 SOL for him. And player 2 has, well, player 1 actually has how many SOL? I think this one has a lot. He has 12. All right, so let's make our bet. So right now, current stock price is 3.9. Let's predict it goes to 3.8. And I'm gonna bet 3 Solana in it. And let's say it's about 150 seconds, right? Eventually, you can set up a function that converts this from days to months. right? But right now we still just want seconds. And now let's go ahead and submit. And again, let's test if create bet still works. Let's go -3, that's good. Hit approve. Create a bet, amazing. So we can alt tab to here and let's see what it says. Can we see it? Yes. All right, so the pot to match is 3. Let's hit enter and I'll predict it's gonna be 8 Solana. So this one is gonna be wrong. So let's see, -3 Sol, approve. Let's go, he entered the bet, right? So we can X this out. And then now, if you just look at 8T and look at the status of the bet here, 3 Sol, it's gonna say claim now, right? It said enter before, but because of our ternary operator, it now says claim. Next thing we have to do is the final function of today, guys, which is claiming the bet. And you remember, this is the complicated one, but we did the heavy lifting in Solana Playground. And if you look, if I did fetch here, there's our bet, right? We can see player A, who's 8T, and then 3W, which is player B. And you can even see the guesses if you fetch it. So cool. All right, so let's go ahead and work on our last function. All right, so right now we want to claim the bet, but as you can see, I'm clicking it. There's no functionality. So let's give it life and let's go to prediction app and let's go, we can go down below here and say const claim bet, right? And you guys should know the pattern by now. We're gonna use callback, and this structure of calling the Solana instructions is the same. So if you want to make your own dApp, keep this structure in mind. If you don't learn anything from here, just learn that this is how I create a function. This is how I call the function, right? Those things are going to help you make your app. So here we go. Claiming a bet. All it needs is the bet that's selected. And then we have our edge case here. What's our edge case? If there's no master account, just hit return. All right, you with me? Home stretch, guys. Then we do our handy dandy try catch here with E, and you know I like to console.log couldn't claim, and then show me why I couldn't claim with E.message. And this has to be a comma actually outside the quotes. Okay, and we also do a toast dot error here, and then we can say failed to claim. Okay, cool. Now for the try, which is going to be simply just const tx hash is equal to program, or await program dot methods, right? So we're gonna call the last instruction here, which is just going to be claim bet. Okay, and claim bet doesn't take anything, but what does take stuff is the accounts that we pass in, which is just gonna be well, actually, it's gonna be a couple of things now that I think about it. It's gonna be the bet, right? Which should be the await get bet account PK and pass in the bet.id. And then from there, we can pass in the pith, right? The pith is just the bet.pith price key, because we have to validate if that's the correct key. And then we got player A and player B, right? So player A, how do we get their key? Well, we stored it in the bet account itself. So we need to get to the prediction A.player, right? How do I know this is what it needs? Well, if I go to Solana Playground, I go to the account, and then inside that go .prediction A, and then go to player to get that. Same thing with B. So let's do that, prediction A and .player, comma, let's put player B. Player B here is going to be same thing, bet.prediction, and then we say b.player. Last but not least, we need the signer, and that is essentially who's claiming, right? So wallet.public key. The cool thing is that anybody can claim. Player A can claim and player B can claim. So let's say player A won and player B lost. If player B claims, the money still gets transferred to player A. Right, that's how we set it up, which is pretty handy. So then from here, you can just say .rpc, and then you can say toast.success claimed bet. All right, hit save. And we also, I don't know if I did this for the other one, but we need to put the dependency module for master account. Yeah, I don't believe I did that for the last one. So let's do dependency module master account. same thing, comma. This is for the use callback part. Yep, and I did that here. Alrighty. So with that said, we can now claim the bet, and now we just have to go ahead and test it. So I'm going to do this, and then where are we going to claim the bet? You saw the button, so it should be around here. So instead of the static claim bet, we need the real claim bet, and we should also press equals this so it doesn't run right away when the page loads. And we might get an error because this is here, the static one, and we need to pull it. All right, claim, pull it in from here, save, and we shouldn't have any errors. Awesome. So hopefully enough time has passed since I did that so that we can claim the bet. So here we go, deep breath. Let's see if the claim works. Hopefully enough time has passed or it doesn't give me any errors. Let's go. Do you see that? +6 in our wallet, right? So this took a lot of work to build. If I hit approve, it should go through. Claim the bet. It might take a while for your SOL to update on Phantom. It should have 15 SOL, right? We just made a profit from, predicting whether a stock will go up and down. But I hope you guys learned something today. Comment down below if you liked the video and subscribe. I'll see you guys in the next video. Peace.